Okay, for those of you watching the recording, this is Durwood King with Sampson Community College, and this is the Introduction to PLCs class, ELC 128. And this is June the 16th, 2020. And anyway, we're continuing through our students writing PLC logic programs, running them on the emulator, and then adapting those to a real PLC and sending me the file, and then we run it on a real PLC here, and they get to see it through a webcam. So anyhow, thank you for joining. And if you're not affiliated with our college and you're interested in taking some classes in the industrial systems technology, you can get up with me at dking@sampsoncc.edu, and I'll be glad to answer any questions. I teach the electrical classes, and we also have hydraulics, pneumatics. We have machine shop, welding, refrigeration. We've got a wide variety in the industrial systems. But I teach the electrical portion of that. Okay. So anyhow, we're going to get right on to our session here, and I'm going to flip over to email and save those files that y'all have just sent me. Okay, you should see some email there. And let's see if I go back to the earliest one. Bless you there. I think the earliest one would be Nathan. He just sent the new program. And let's go out to there. And that's for the real McCoy. And then let's go to Kenneth. Sequence control real. I got two. Looks like they may be the same thing, Kenneth.
That's odd. I don't know why it would have sent it twice.
Save as. Go to Kenneth. I'll find out when I save. If it says it's already, it looks like the same file name.
I don't know. I was having some issues with uploading earlier. Maybe it just for some reason.
Right, it says it already exists, so it's the same one. Yeah, that's fine. Okay. All right, so let's see. Let's go back. Cut that off. Yeah, I don't see any other programs that have come in today. Okay. But I'll hear it if they ding in, okay? So let's go ahead and check the roster, and then we'll get started. Glad y'all made it. Got a good turnout already. 6 people. That's good for this early. Okay, and today is the 16th. And so we've got Kenneth. Got Nathan McKee, got Roger, Justin Sokolowski, Eric Martin. Eric, how you doing?
I'm good.
Right. Got Justin, how you doing?
I'm good. How are you?
Pretty good, man. Pretty good. Glad you made it.
Thanks, sir.
Let's see. Benjamin, how you doing, man?
I'm pretty good. I got the emulator ready.
All right, good. Jamie Jones. Jamie, how you doing?
You busy drinking that coffee?
Got 7 on. That's good. Very good. That's a good turnout. Good turnout so far. Just need 18, okay? Okay. And let's see where people are. Okay, Kenneth is completely called up, ready for the new one. Eric is completely called up, ready for the new one. Nathan is, I didn't see yours as far as the timers, Nathan, but we can, I think you sent me files. We just haven't run them.
Yeah, I think so.
Yeah. And let's see. So you're at school?
Yep.
Yep, I see you there. Yep.
Yep, I'm pretty much at school every day.
Yep. I've been doing most of my stuff from home. I took so much stuff home. I've got, little by little, I've just about filled this room up here at the house,
Yeah.
Yeah. And right now, Butterball's not here. They're kind of in a bind for help, so they can't send people over here now for training. And so I'm just putting all my time on curriculum pretty much right now.
Yeah.
And they got me set up for a Con Ed electrical class to do online, a Zoom class starting in July, because Butterball's not projected to be here then. So they're going to get me doing some public stuff for Con Ed as an alternate,
Yeah. Yeah, it's pretty quiet here every day.
Mm-hmm, yeah. Oh, yeah.
Especially since BLET just graduated
Mm-hmm.
a couple days ago.
Yeah. Let's see. And so I guess what we can do here is we got a new program to do tonight, but it would be fair to go ahead and get people checked on programs that they've already sent, and then we start the new one. Does that sound all right to y'all?
Yep.
Let's do that, and we'll just so Nathan, since you're on right now, we'll go ahead and we'll check your timers. Okay.
Now, when you say timer, you're not talking about the motor, not the 3 motor starters, right? The actual timers.
Yeah. Mm-hmm.
Or that right there.
Well, no, this one is a new one.
Right.
That's a new one for tonight. Just got the three starters. That's my program that I sent y'all. Let's go and look at the files that you've sent for the regular timers. Okay.
I see you the brand new one though.
Mm-hmm.
The one you just showed.
Yep, I see that one right there. Yeah. So if let's just back up to your TON.
Okay.
And we'll just quickly go through that one. Okay, that's your emulator. Okay. Yep. You see that?
Yep.
Okay, so that's the emulator. Start button, enable, done. Okay. So let me go ahead and check you off on that one. Well, I actually saw this one the other night because I got you checked off on it on the TOF. Now that's a real one for off delay. So where's the real one for on delay?
I guess I'll have to send it to you. Let me send it to you.
Oh, okay.
What's going on, Mr. Durwood?
Hey, how you doing, Dylan?
I'm doing all right.
Good. Glad you made it.
Document Studio 5000 projects. All right, so you need the RT TON
real on the real one.
Find it. TON timer.
I got the TOF on the compact Logix, and I've got the RTO. Well, let's see if that RTO is if that's emulator or real. Okay, that RTO is also emulator. But I'll go ahead and put you down for it. Stop. All right. Enable. Done. and reset. That one looks fine as far as
Okay.
the emulator. Let's go back and look again at your
TOF, TON, and what was the other one? RTO logic. Compact logic. Okay, let me delete that one. TOF.
I've got your TOF on the real one. We can go ahead and run it while you're getting this in here ready.
Okay.
Do y'all see the logic? Do y'all see the program?
Yep.
Okay.
Yeah.
So we'll go ahead and download it. I'll go ahead and do that while you're getting your other one.
Okay. I just sent you all the other real ones.
Okay.
All three of them together, just so
Okay.
you have them. But now, do you need to see my logic one? Did you say of any three of those? TOF, TON, or RTO? Let's see. I've got too many windows open. Hang on a second.
Yeah, I do that all the time.
I've got 3 monitors running,
Woo.
and one behind me. It's almost too much. All right, it's good for grading though. Let's see. Failed to go along with the controller connection time tab.
We'll move the webcam over. Get it in position. Okay, I'm downloading your real TOF. And I've got it zoomed in. You can see the 2 push buttons and the starter right there. That's about as close as I can get to see both. Okay. Now, so if I hit the stop button, you see it go away. I release it, it comes back. I'm gonna hit start. Now with a TOF, your fan is going to come on instantly with no delay, and the timer won't do anything. The timer won't count. The timer won't start count. Hold on a second. Why is it doing that? Okay. This. Okay, now the accumulated value in the beginning is already at the max at 10 seconds. When I hit the start button, look at what happens. Hit the start button. The load comes on instantly. The enable output of the timer comes on instant, and the done bit comes on. The enable is giving you. Do y'all see my mouse moving around?
Yep.
The enable bit of the timer is functioning as a holding contact here. That's the connection there. And then the done bit is instant. So the enable and the done are instant on the TOF, on the off delay. It's instant in the beginning. and the accumulator resets itself to 0. So that fan will come on instant light for oven, for instance. And when I hit stop is when you see the accumulator start, but it keeps the load on while it counts. So right now, as soon as I hit stop and this run goes false, the timer starts. And it goes at the 10 seconds, and then the load, then the done goes off. So it's a post delay after you cut things off. When you hit the stop button, we're going to say that would cut off the combustion chamber for an oven, but it would let the fan run for X amount of time longer. So yours is working fine. You see the starter down there? Is it came in?
Yep.
Right here. Pulled in.
Yep.
I'm gonna cut it off. So that could be for a recirculation fan from a combustion chamber in through the oven, and it would keep the, after you cut the fire off, it would keep the air coming out of the firebox to cool things down quicker. Okay. That's good. And so let me check you off on that one. That's the real one. And let's see. That's TOF on real. Let's go back and see. You said you just sent the emails.
Yep.
So yeah, I see you got the TON. Good. And RTO real. And the TOF I've already got. So just those two I needed to.
Okay. I just sent all three of them together. And I just sent you the Logix ones. You said you didn't have some of the Logix ones, maybe?
On the emulator?
Yeah.
Okay.
Or I don't even know if you need those.
Well, you can show me how they work on your computer. That's kind of what we want. We want you to be able to run them. Mm-hmm. Have you tried them? I mean, I know you have.
Yeah.
You've seen them run.
Yep.
Okay. All right. So for the sake of time, what we'll do is let me just see what they look like real quick. Make sure they look good, and we'll just watch the real ones for right now. That way we can move on to the new thing tonight.
Okay.
So let's go back. Save as. And then she already had two of those. Let's cut that off. Go back to here. All right, now, so let's back up to TON, what you have on TON. TON compact Logix, okay? Go there. Go there. And we're going to download. I'll spot check and ask you periodically, how did you do it?
Okay.
I'm gonna try not to linger too long on the catch-up stuff. As long as I can see it kind of briefly, we'll run on. Okay, so I'm gonna hit start button. There you go. And then there's your starter in the webcam. You'll see it after 10 seconds. It'll come on where I'm pointing at now. Right there. There it went. You heard the click. So that's perfect. And the accumulator stays where it is, and the fan's going to run indefinitely until you hit stop, and then it's going to clear the accumulator. So hit stop, cuts the fan off, and it clears the accumulator. So that's characteristic of a TON. And it functions like a real plug-in timer, like if you were going to do it, a hardwired timer. That's like a module that plugs in a relay socket, relay base. This functions the same way, but you don't have to have anything physical there. It's all, you can do hundreds of timers in a program like this for free. And you don't have to wire anything. You don't have to wire the timer. You just have to wire the input buttons and the output devices at all. So you save a lot of space with PLCs. Okay, so this is the real one for TON. All right, now let's check your RTO. Go out. And let's see. There. Okay, attachments are active. There. Okay, so there goes your RTO. I'm going to hit start, and now if I hit stop, look at what happens. It keeps that accumulated value.
Yep.
It'll also keep it if we cycle power too. We start again, stop again. But that's kind of like if you ran for a whole day and you killed the power, you come back tomorrow and you run again. You'll be able to keep up with all that run time over a period of days if you put enough time in there, and it'll keep up like a service timer would. Even when the power goes off, it's going to remember. So let it finish. They use these for automatic lubricating devices. They use it for physical maintenance that needs to be done, like oil changes and filters and part changes on things that wear out. Okay, so that was your service light, and that yellow light came on right there. You see the yellow light's on now.
Yep.
So it's going to stay on until you do the service, a manual service of whatever you do, and then when you hit the light, hit the push button. Let's see if I can manage to. Let's see it. Input 7. If I go up. To go kind of up, kind of high. Just see all this. Okay. So you see in the webcam, you see the button way over here.
Yes.
That green button, and it's gonna cut that light off. So I hit the button, and it goes off. So you see the data.7 coming on in the program right now, and then it's off, and then it comes on. So this is the physical acknowledge button that says I've done the maintenance, and it's going to reset that service timer. Okay, and that's just one example that you could use that timer for. These timers can do anything you want them to do, pretty much up to your imagination. That's just one example. Okay, all right, let me sign you off on that one. Now that's got you on all your timers. The only one I hadn't seen is your TOF on your emulator, and I can spot check it real quick.
Okay.
TOF, just plain logic. And that's TOF. Done. Yeah, that's fine. That's fine. Okay. And just for sake of time, we'll just, I know that works, and you've seen it run on your computer.
Yes.
The important thing is that you see it run and that you got your hands on the logic and that you understand you can create any kind of logic you want to in that emulator. It's going to run it like a real machine, and it's good for development, you know. Okay, that's got you. That's good. Now let's see who else is next. Benjamin, you got one, right? I'm just looking right straight down the list. I see Benjamin on there.
Yeah, I sent you the 3 timers for the Real PLC.
Mm-hmm. Yeah.
And I don't know if you want to see the emulator for them.
Yeah. Do you have the emulator versions ready?
I only have the TOF ready. I still have to do some tweaking to the RTO.
How about the TON?
I showed you that last class.
Let's see. You did?
Yes, sir.
Okay. Let's. I didn't check you off on it. Hold on. Let's go back to let's go back to the Logix here. Okay, TON. I see TON right there. That's the real one. Let's go ahead and check the real one. Yeah. And you can just screen share and show me the other one, and we won't run it. I just if you can just show it to me.
Okay.
Have you run it on your computer?
Yes, sir.
You did. Okay. All right. Okay. So let's download this one. How do I download it?
Who active? Well, communications. Who active? AB Internet. 130, and download.
We're going to get into some troubleshooting on the next project that's for 3 motor starters. Once we go through it and I see y'all's, I'm going to start putting some bugs in this thing. That'll be a good one to put bugs in and let y'all help me debug it with the webcam. We got to put some troubleshooting in this class, huh? Okay. So I'm going to hit start button, and there it goes. And the starter is right down here. You'll see, come on. There it went. Okay, that's good. Perfect. Hit the stop button. It's going to clear it. There it went. Y'all hear? Y'all can hear that pretty good, can't you? The clicking.
Yeah.
Okay, good. Let's see, Benjamin. All right, so I got you on the TON, Benjamin. Let's check your other ones. TOF. Good, that's the real. Good. And you've already told me how to download one time, so I'm gonna go ahead and just let it rip. And just every so often I'll spot check you on it. I won't drag everything out like that every time. Because there's a lot of y'all waiting to get checked, and I'm gonna try to get everybody several times tonight. Try to. Okay, so there you go. We're gonna hit the start button, and the fan comes on instant with no delay. The accumulator's at 0 because it hasn't started timing yet. Now hit stop, and then it begins to time. So it's giving you a cool down period for that fan, for the oven. After 10 seconds, you'll see it cut off. There it went. Okay, perfect. So that's got Benjamin on off delay. And now let's see your RTO. RTO. Y'all doing great. Fantastic. Fantastic. Like Trump says, you're doing a fantastic job. You know, fabulous, remarkable. Okay. Download. Okay. All right, hit start button, hit stop, and it holds that time. Even if I hit stop again, it'll hold it. And then even if did you see us power it down one time, Benjamin?
Yes, sir.
And it holds the time. So it's the R means retentive through a power outage. Okay. So that could be a matter of days, or you know, that timer can go really high. You can also cascade timers and let one timer start another one, and lengthen them way out to make it be like over a long period of time. Okay, that's good. And so what you're calling service light's actually cutting on a starter, which is okay. And now, if I hit stop here, If I hit stop, you notice that it doesn't clear it, right? So just hitting the stop button is not going to clear that. The only thing that's going to do it is the push button up here is going to clear it. Okay, that's good. Because of the nature of it, it's retentive. It has to be told to reset, either by a manual signal or by or either by some logic that you put automatic in your program. So that reset could be automatic. By whatever logic you come up with can make it reset after something happens by itself. Maybe after a lubrication cycle, you can have after the lubrication cycle finishes, you can have something to actually trigger where it's .7, input 7. You could have an automatic contact in there and reset that timer after it does its automatic loop cycle. Okay, that's good. All right. So I'm going to cut screen share off. And did you say you had your emulators?
Yeah, only for the TOF.
Okay, TOF. You want to run that one time?
Yeah, I'm about to. It doesn't let me screen share.
Hold on. Okay, I didn't have it turned on for y'all. You go ahead.
All right.
I see Jameson's come in. How you doing, Jameson?
Well, I'm doing good.
All right, good.
I'm back.
Right. Well, you want to toggle that start button off. Right. Now toggle the stop button on. But that's the way it will start there. So now toggle the start button on and off. Okay. Now, so that the fan comes on instant. Now toggle the stop button off and back on, and then you'll see it start. Okay. And then the stop button back on. Right. That's the normal way it would be on a physical button. That's good. That's good. Okay. That's good.
I just got to do some stuff to my RTO, and I'll let you know when I'm ready.
Okay. We can just move on from where we are tonight. We'll focus on the new stuff tonight. You can back up on that later.
Okay.
Hey, Durwood.
Yes, sir.
I think I got my emulator ready, but not actual.
Okay, go ahead. By the way, I emailed y'all two documents this afternoon right before class. I've also put them in Moodle, but I went on ahead and emailed them straight to you so that you would know that it would be noticeable. And it's actually a hard copy printout of the new program for tonight with all the real addresses in there and everything. I did a printout this afternoon. I sent you a printout of the whole thing. Plus, I sent you the wiring diagram for this new one tonight. So you got both of those in your email.
Yeah, I saw that on the website, and I saw I'd missed one of the alarms for the first one, so I had to add that real quick.
Yeah. Mm-hmm.
I believe that was the only thing.
Okay, so what Roger's got here, y'all, is he's got the new one for tonight, which has got 3 motor starters that are going to start. The first one starts instant, and then there's a delay timer, and then after the delay finishes, the second starter starts, and while the second starter is going, it starts another timer that's a delay for the third one.
Everything right.
Okay, that's your overload. Yes, sir. The alarm. Start 2, start a light. So if you'll toggle that start on and off, and let's watch it. Let's scroll down through the program. You toggle on, toggle off. There you go, perfect. So his timer's timing. Now scroll down a little bit. Perfect. It started the next one. And now after the next one finishes, the third one comes on. Now, so you saw 3 timers, you saw 3 starters come on in a sequence. You get down to the bottom of it. Do what, Roger?
I said so 2 timers, 3 starters.
2 timers and 3 starters. Now, if you toggle one of your overloads, then it causes an alarm. You don't hear it yet. You'll hear a real one on mine. And what it does is it shuts off all of its starters.
Okay, I was wondering what that did because I was sitting there thinking, well, it ain't doing anything.
Yeah, it shut everything off.
Gotcha.
So if you have just one out of 3 of those starters to trip on overload, we got the overloads physically wired to inputs. We're going to go through the wiring in a minute. I'm going to show you how the wiring is actually done. Actually, I can show you real quick how the physical wiring is done. Let me put you down for that one. Let's see.
So we should follow the screenshot that you sent us for the real one.
Yeah. Mm-hmm.
All right.
So I'm going to put you down for emulator on this one here, Roger.
Uh-huh.
That's good. And so y'all can know about what was the deal with those overloads as inputs. I'll show you something. Hold on, let's cut this here off. Let me go back to can't do that. Okay, let's see. I'm gonna pull up the two drawings that I sent y'all. Okay, do y'all see that?
Yeah.
Yes.
Oh, you did?
We can see it.
Okay. Now, do you see my mouse moving around?
Yes, sir.
Now, so you see there's 3 normally open contacts that are on input 8, 9, and 10.
Yep.
Now, that's motor 1 overload relay contact that's normally open. Now, let's talk about the motor starter itself. This is something that some of you, it'll be new to some of you. Okay. I'm gonna bring my webcam down, and this is a little lesson on motor controls that you've got to have to go with this lab here. Now, so this, do y'all see in the webcam this motor starter I have in my hand?
Yes.
Down here is the overload relay that's a separate part from this. If I take these 3 screws loose, this here will come apart. If I just loosen them up and show you that it is a separate thing that bolts on. Now, y'all see that? Now watch. It's going to come apart like that. See that? See
Oh, yeah, I remember
those
that
copper
noise.
tabs right there. So when the power comes through the top part, the contactor portion, when it pulls in, I pulled that lid off there. When I put power on the coil for A1 and A2, it pulls the armature in, it draws it in, and it'll bring power from these 3 down through these 3 into these 3 solid copper lines here that goes into the overload relay. Now the overload relay has a normally closed over here, and it's got a normally open. Now here's what happens when this overload relay, when it trips, and it trips on too much current. If I open the lid up right here, open the lid up, and do you see that dial there? Let me flip to a larger screen there so I know that you're seeing this. Okay, do you see that range of numbers there on this adjustment? See how I'm moving that around? Everybody see that? So it can go from 5.5 amps up to 8 amps. So the range for this overload is from 5.5 amps up to 8 amps. And you can buy these in different ranges that can start at a higher number and go way higher. That's just one example. And this setting right here, you would set this to 125% of the current rating of the motor. So if you see like this motor over here, you see that motor? That motor is going to have an amp rating. It's going to have an amp rating on that data plate. It's going to say FLA, full load amps. So when you get to the full load amps, I know it's upside down. But hold on. I can fix that real quick. I'm going to try to be steady on this and point. You see where my screwdriver is?
Kinda.
Kinda, yeah. It's fuzzy, isn't it?
Mm-hmm. Yep.
Let me move around here and try to get it where you can see what's going on. That's about as sharp as it's going to get right there. So you see where it says A over here? A is for amps. Hold on. A. Where the A is, it says 2.3 amps to 2.4 amps, and it'll draw that many amps at the lower voltage. You see the V up here where it says V? Can y'all make any of that out?
Not really. I can make it. I can make it out a little bit. I see the A on there.
Okay, you see the A and you see the V. Yep. Up here.
Yeah.
For the voltage, it can run from 208 to 230 on low voltage, and that correlates with the amps of 2.3 amps to 2.4 amps. So whatever voltage you're running at, it could be 208, 230, or it could be 460. Whatever voltage rating you're running the motor at, then you go down on the amp line and you get the particular amp rating at a given voltage. So you go directly under the voltage and you'll see the amp setting. So you get the amp rating off of this and you multiply it by 1.25. And then you physically set the overload relay to 125% of the amp rating that you're running at. So I know it's hard to see that because I don't have the best camera in the world. We got a whole lot better ones on the way. The school has ordered some very specific ones for what I'm doing right now. They found a very good kind of camera that's called a document camera for showing small print on documents like this, and they've got them ordered. So I got something on the way a whole lot better than this camera. But bottom line, when you get that amp rating off of that motor nameplate at a given voltage, Then you come over to the overload relay. And this is something even in motor controls that you guys, I don't think we some of you didn't even see this in motor controls, I don't think. So you would set the dial. That's an adjustable trip setting. So if you exceed the setting on that dial, then it's going to trip. Now listen real good. When it trips, you see where that says NC for normally closed here? And that says NO for normally open. Do y'all see the NO, and the NC?
Yes.
Yeah.
Now watch this. Watch it really close here, and listen good to the meter. I'm going to have the meter to do a ring for you. So I'm kind of putting the meter right beside of this. I'm going to put it on ohms. Now, when I put it on ohms and I bring the leads together, you hear the ringing? And it's giving me the resistance of the test leads, which is, and if they're kind of high, you can just move them apart like that. The probes, if they're quick connects, you may want to reseat those to get a lower reading there. It's supposed to be down around 0 ohms. That's 8 ohms. That's a little higher than it ought to be for that meter there. But you hear the ring, right? You would subtract that number 6 from whatever reading. If you're checking resistance on something, when you touch these together, you just subtract that from whatever device you have, and that's going to subtract the resistance of the test leads of the leads here. Okay, so let's go here. Let's go here to the normally closed portion right there. You hear it ring? Everybody hear it ring?
Yep.
Yeah.
Now, so when everything's cool, when the motor circuit is fine and you're not drawing too much current, the normally closed is going to be closed. Okay. Let's take a look at the schematic. Let's put the schematic right beside of this so you can see what's going on. So right here, the normally closed is ringing right now. Is actually, you see that normally closed I'm pointing at with my finger?
Yes, sir.
That's the overload, the normally closed portion that's wired in series with the coil. So when it comes out of the PLC on output 1, it goes through the coil, and the coil is A1 and A2. They're just A1 and A2. That's the terminals. That's your standard letters on all brands. It's A1 and A2 for a coil. So the power goes from the PLC to the coil, which would be here, and then it leaves the coil with a short jumper wire and runs from here to the overload relay to normally close. So it goes from A2 here over into there with a short jumper wire. As you see here, you see these? You're going here from A2 around to 95. You see that?
Mm-hmm.
So that's how you connect the coil, the A2 part of the coil, over to the overload relay. It enters the overload relay there, and it leaves here, and it goes on to the real neutral in the system. So that's how that ties in on the normally closed portion, which is right here. So the PLC drives the coil on A1, and then I didn't have it labeled in there. And then the A2 goes over to the overload relay to 95, then it leaves 96, and it goes back to the real neutral. So that takes care of the normally closed portion. So the new thing we're adding tonight is the normally open portion. The normally open portion is used to signal a PLC, to tell a PLC, hey, this thing is tripped. So the normally closed is used to actually physically protect the normally closed protects this. It actually shuts the coil off if any of those 3 leads to the motor drawing too many amps. It's going to pop open that normally closed, And when it does, it's going to disable the coil here by cutting off the neutral leg. It's not going to cut off power from the PLC. It's just going to kill the neutral, which will actually cause the starter to disengage and go home and open, okay? So let's take a look right here. All right, you hear that ringing, right?
Yep.
Now let's go to the normally open. Now what do you see there? You don't hear anything, do you?
Nope.
The normally open is open right now, and look over on this diagram up here. Do you see that? You see that normally open there? That's the normally open on the overload that feeds into the PLC to an input. So what happens here is when this overload trips, here's what's going to happen. And I'm going to trip it right now. Now watch. I'm going to open up this door here, and we're going to trip it. Now, I want you to see what happens. So right now, the normally closed is closed, right? Now watch. If I go inside of that window with a screwdriver and I slide the window over, listen to it, it's going to quit. You see that? Do you see in the window where it has a T in there?
Yep.
The T means it's in test mode and it's tripped. So right now, the normally closed has actually popped open on the diagram. Y'all see the diagram?
Yep.
So it's popped open. Now, what happened to the normally open over here? Now the normally open is made. You see that? What was not made a while ago is when it tripped, and you see the T there, it's tripped. The normally open now is closed. So the normally closed open, it went to the opposite state. And when it did, it actually cut the neutral leg and it made the coil disengage. But at the same time, the normally open portion of the overload relay is used to send a message to the PLC that says, this thing tripped, you better kill the power to the logic. So this is used to signal your control system and to say, hey, there's a problem out here. Don't, turn the coil off. This normally open goes into the program and it tells the program to shut your logic off. So do y'all see over here that normally open? And now it's closed. You see it?
Yep.
I think you can see everything. You hear the ring, and what was normally open is now closed. And now over here where I'm pointing at, it's closed, and it's going to get an input, the input 8. You see that?
Yep. Yep.
Everybody understand? So tonight's what you saw with Roger a while ago is he had all three of these normally open overloads in his program in parallel. He actually arranged them. They're separate inputs, but he arranged input 8, 9, and 10 in his emulator in parallel so that if any of them actually come on, which means that one of the starters out here tripped, it means that one of these three has tripped. One of these three tripped. And they're going to send a message. You see the orange wires I've added in? I put 24 volts DC going into the normally open on every one of them. I got 24 volts here, 24 there, and 24 there. So 24 volts is feeding into the normally open, and then leaving each normally open is going back to the PLC. That's a signal to the PLC. That's another one to the PLC, and then there goes the third one to the PLC. So these are sending an input to the PLC to say, hey, this tripped or this tripped or this tripped. And then the logic is going to actually shut off the coils. So the logic goes in there and shuts off the coil voltage up to here to the coil so that your logic is not still trying to run the starters. Does that make sense?
Yep. Yep.
So basically, the normally closed protects the physical device out here quickly, but the normally open signals your control system so that you can logically shut off the logic that's driving these starters. You say, well, why would we do that? Why you would do that is because if you don't shut the logic off that's driving these coils here, and I'll just give you a scenario. Let's say if number one tripped out. If it tripped, the normally closed would actually disengage the coil, right? Well, what happens is when this thing cools down and you reset it by hitting that blue button and you reset it, the logic that's driving that coil is still on. If it's still on, as soon as you hit the reset button, it's going to come back on right then before you have to go over and hit the start button. See that? So you have to get your logic. You want your logic to know by way of this normally open that this thing tripped, and you want your logic to go in there and shut the coils off. So that once you clear the fault, if you can clear it just by hitting the button. You know, if the motor that drives if that motor just got jammed up on the machine just by material jamming on the machine, not by a bad motor, but just by something jamming on the machine, you can clear the jam and then reset it here, and then you would want to go back and hit the start button again, right? Instead of it all of a sudden jumping back on by itself when you hit the reset button. You don't want to hit the reset and it just start on its own. And that would happen unless you actually turned off the coil voltage to the starter. Does that make sense?
Yep. Mm-hmm.
All right. So that's the logic behind that. And these three signals right here. Again, I've got the 24 going into all of them. These three separate signals leaving there on each one of these, they're feeding the inputs up top here. And I'll just show you where they're going. Okay, I added, if you see, let's go in. I don't know how well you can see those numbers in the blue over there, but do you see on that strip there? It says 08, 09, and then 10 on the right side there.
Yep.
So input 8, 9, and 10 are some new wires I added this afternoon, and they're right over here. So there goes input 8, 9, and 10. Now, just so you can see the lights come on for 8, 9, and 10. You have 8, 9, and 10 on the LEDs. I'm going to trip one of them right now and let you actually see the light come on so you can actually see what's happening. So I'm going to pop open the lid down here. Now, do y'all see me getting ready to trip this overload down here?
Mm-hmm. Yep.
I'm going to trip it. You see that input come on?
Mm-hmm.
Now, I'm going to hit the reset button, the blue button. You're going to see that go away now. You see it? Now, I'm going to go over and trip the other one for starter 2. Now, you see that light come on?
Yep.
That's input 9 for starter 2 overload. Now, if I hit the blue button on the overload, it's going to clear it. You see that go away?
Yeah.
I'm going to trip the third one. And again, all I'm doing is I'm down here. I open up the window on this overload, and I go in. And this is only for a Snyder brand overload that you go in with a screwdriver and slide it over. So Allen Bradley, they have you don't really slide it over. You just hit a button. It's just a button instead of having to actually slide a window over. But here, it made input 10 come on. You see that? Now, when I hit the reset button on the overload, that goes away. You see it? So 8, 9, and 10. This is how the PLC knows on the inputs what the overload relays are doing. So that's how it's like a watchdog thing to where they're, the PLC can monitor those normally opens. Is everybody got that?
Yep.
Okay. So that's what you're going to physically be programming in those those normally opens there. All right. But we're using both. You know, we're using both. Do any of you from motor controls remember, do y'all remember us going over not only the normally closed, but do you remember us talking about normally opens, overloads being used? I don't really know that I've even discussed that with all of y'all. Connor and Cameron, do y'all? Let's see.
I don't think I remember.
Pretty much what I remember you discussing
I think
was
you
just how
touched on it a little bit. We didn't go very in depth on it.
Right. The only place that this was used would have been on that big lab bolt trainer, the roll around unit. And this was actually used on that unit not to drive a PLC, but to turn the yellow light on. So you can have that normally open that can turn on just that can turn an indicator light on directly instead of going to a PLC. In other words, one of these indicator lights down here, you could turn on a yellow light with that contact, not having it feeding the PLC, but just let that contact turn on the indicator so that on the panel, the operator knows that starter tripped. And that could come in handy in a noisy area to where you got a lot of motors running and one of them cuts off and they might not even recognize one pump being off out of 20 pumps, you know. So if you got lights and you're using this to turn lights on, that's one option. You know, you could have it turn the light on, plus you could actually have it going to the PLC also at the same time. So that contact could actually feed more than one thing, you know.
Seems like all we did with that conveyor was just wire it up. I think.
Right, with a conveyor, yeah.
Yeah,
but
that's all we did with that. I don't think we talked about the normally open.
I'm talking about not on the conveyor, but on that large lab bolt unit that's near the classroom, that tall one. That had the VFDs in it.
Oh, yeah.
The two larger cabinets on the left, closer to the classroom, they had a yellow light. They had a yellow light on the front of the panel, and that yellow light was actually an overload light that was actually turned on by a normally open overload contact like this. And if you didn't happen to do that, lab, you may you know, we may not have had time to even let you do it, you know. But it was using a normally open portion to turn on a yellow light. So just keep in mind that most of the overload relays, they're going to have the normally closed and normally open, but everybody doesn't use normally open, but it's a good thing to use because it's a signal to something else. That's your interface to something else to say, either with a light or with a PLC reaction, that starter is tripped. It's a way for this overload to talk to something else and to have interaction with something else. So anyway, okay. So in this here, those of you that hadn't had motor controls, you see how that mates up like that? It goes in. When they're apart, this is called a contactor, and that's called an overload relay. When you put them together, it's called a motor starter. It just becomes a motor starter when you do it that way. The contactor portion can be used just for lighting or for heaters, where you may not use an overload on them. Well, you might not use overload relay, I'll say that. All right, so now, I didn't mean to be long and drawn out with that, but okay, so you see how that works there, and let's get let's go back up. That'll let you see everything at one time when we run all three of them. Okay, so let's go back to the Logix. And that was, whose was this? I don't see a name on this. I've already forgot who this was. Let's go back. We go back to the file and it'll tell me whose it was. That was Benjamin's. Okay.
I got my RTO emulator ready.
Okay. All right. I'm gonna put you down for the RTO for the real. And I did that. You're clear on all three of them. I'll cut the screen share off. Okay, go ahead.
All right.
Yeah, go. Well, you got to talk. Yeah, you got to have the stop on. Now toggle to start, on and off. Okay, now hit the stop button. Wait a minute. Yours is already done. You got to reset it with the reset button. You got to toggle your reset button on. Yeah, yours is already timed out. Okay, it cleared. Now release that. Now go back and let's run one time. Now toggle on, toggle off. Okay. So it's timing. Now hit the stop button. Okay, you see how it kept the time?
Yes, sir.
So it keeps it on the emulator just like it does on the real thing. Now let it go ahead and finish.
Do I hit the stop again, right?
Yeah, you have to get the stop and the start, yeah.
Okay.
And then toggle to start off and on. So now when it's finished, the only thing that's going to clear it is going to be a reset, which you've already done that. So you're good there. All right, I got you on RTO. Okay. And did you run the TON on the emulator?
I did it, like I said, the last class.
If you showed me the other night, I'm gonna take your word for it. So you're done on timers. That's good. Okay, good. Let's see. New people have come in. Let me get y'all counted on the roll here. I see Connor and Cameron both.
Yeah, we're both here. Yeah, we're both here.
Good. Okay, I see.
Yeah, it took us a while to get in. Our Zoom didn't want to work.
Zoom didn't want to work.
Yeah, I don't know what was wrong with it.
Yeah, sometimes you gotta have to just get out and then come back in to do it again.
Yeah.
Yeah.
Up here somehow. I don't even think it's how I normally get in, but through the app or something. I'm not sure exactly.
I think your audio's cutting in and out, but if you're in, they're good.
Yeah.
Okay. Okay. So Dylan Ivy, if you go back up to Connor, what do y'all have anything to? Let me look to see what's actually due here.
Yeah, I got something you can check if you want to. Let me open it up real quick.
Yeah, your timers.
Yeah, one of my timer emulators, and I think I have a problem with it actually. So if I can find it and open it, you might help me out.
Have you sent me any of the timers as far as to run?
No, I haven't sent you any of the actual timers.
Okay. But do you have any emulator timers ready?
Yeah, I have the TOF, but I'm doing the other one right now. But I'm trying to figure. Let's see. Can you see my screen?
Yeah, I see it. That looks good.
Okay. So whenever I go to try to go to communications, and then go to active, you see that red X on the
Right.
and it failed.
Okay.
Well, I had the emulator pulled up, and I thought if I exited out of the emulator, and then come back and I exited out, and now I can't pull back up the emulator again.
So minimize this screen. Let's look at your emulator. Yeah, you want to put them icons on your desktop. It says you're already running it.
Yeah, but it isn't running anywhere. You see, whenever I hit OK,
Well,
and OK,
look. Okay, listen. Let's do this right here. If you can't find it anywhere, go down to the bottom of your taskbar and right click and hit Task Manager. No, take your mouse and go to a blank area down on your bottom bar. Way on down further. Now right click and hit Task Manager. Component of the RS Logix application. Now, do you see? I don't see it running in there.
Yeah, I don't see the emulator.
Huh?
Yeah, I don't see the emulator here.
No, I don't. I don't see it running. So just X out of that screen, and just show me the. Hold on a minute. Another user is actively using the emulator at this time. The only thing the only thing we can do right now is you're gonna probably have to reboot the computer.
Okay.
Doing that, don't kill up time with that. Let's just see your real ones run. Well, we can't do that.
Yeah, well,
Just
well,
show
I'll
me.
just go ahead and
Yeah, just show me the program. Hey, right down there at the bottom, look, wave at the bottom again, and let's see all those other windows you have down there.
yeah.
I still don't see the emulator, but it's okay.
Yeah.
It's fine. Listen, let me just look at what you got. You got the TOF. That looks fine there. That looks fine for TOF. But
All right.
what you can do, I'm gonna go ahead and check you off on that one. And when we get to a point to where you're gonna be working on your programs,
yeah,
and go ahead and restart the computer and try to, and that way maybe the emulator will run then.
Okay.
So that's the emulator for TOF, and that's Connor.
Yes, sir.
Okay. All right, so I've got that. Do you have another one?
I was in the middle of the other one actually.
Okay.
Actually on mine.
Okay. Yeah, the next one will be the RTO. Yeah, I see that.
And I just had to add.
Right. You don't have a reset instruction at the end of that line.
Yeah, that's the only thing I had.
Right.
Where's that reset instruction at actually?
You hit the timer. Hit the timer tab. No, go back up there. Yeah, that timer, and that hit RES.
Okay, there you go.
And now you double left click in the question mark, and you choose the tag that says service timer. You do the drop down, and now you find service timer. You just actually highlight that timer name itself, and that's all. Hit enter, and then enter again, and that's it.
Yeah. All right.
So you can save that one, And probably right now, the best thing for you to do is, save that one, and then cut your screen share off and just, well, I hate to say reset your computer, but you might as well, because it ain't but like 7:15 right now.
Yeah, okay.
So that's what I would do. And that way you can run the emulator, because we really need to see y'all run the emulator.
Okay.
Yeah.
Well, I might go ahead and run the other two for my timers before I do that.
Right. If you want to go ahead and write the real programs,
Yeah.
and then email them to me, and then maybe reset the computer then.
Yeah. Okay. Yeah,
Okay. That'll work.
All right. That sounds good. I'll end my screen share.
Okay. And let's see. How about Dylan Ivy?
I got the emulators ready for you.
Okay. And all I'm doing, I'm looking at the list of who's in the class. I'm not really doing favorites or anything. I'm just going down the list. Mm-hmm.
All right.
Okay.
We got start.
Yeah. Toggle that back off.
And then.
Yeah. See, it keeps the time. Yep. Okay. Now let it finish. Perfect. Good. That's it. Okay. Very good.
All right. And I'll open my, what else the other one I had?
Now, I don't have you down for the TON or the TOF.
Yeah, that's what I'm about. So here's the TOF I'm pulling up.
Okay. Yep, y'all getting really good at this. I'm just thankful that we got the emulator to work with. You guys are you're getting pretty close to the real thing right there. And you basically are, and then you're seeing the real one on my end through the camera. So you're about 99% as close as you can get to being at school. With this by doing what you're doing and then using the webcam. At least starting in August, as far as I know, we're planning on having all the labs to be done on campus. Okay, so you notice the fan came on instantly, and now whenever you hit the stop button, you'll see it start timing. You see it timing, and then it's going to be like a post delay before it shuts off. So that's like a cool down period, or a cool down fan. Perfect. That's it. Okay. Good. I got you checked off.
And what did I name this one?
It will be the TON.
Yeah. So I haven't completed TON yet, but I've gotten the time control one too right here, the one for tonight.
Okay, good. Yeah, good. Okay, motor starter 1, green light. Okay, good. So those of you that hadn't done the new one yet, look at what he's got on the emulator. This is a new one for tonight. It's got 3 starters that start in a time sequence. And I sent you through email just before class. I sent you a printout of this program with all the correct addresses in it and everything, all the correct tags and addresses of real IO. Plus I sent you the wiring schematic. So I sent 2 different emails and you got all that in your email. It's also in Moodle, but I sent it straight to your email so that you wouldn't have to go looking for it. Okay, and scroll on down. So you got the first.
Can't see that, can y'all?
Yeah, I can. It's kind of small, but I can see it, you know.
All right, so let's go ahead and toggle that on.
Actually, the last overload relay, I can't see the last overload relay.
I'll scroll down with it as the timers
As
progress.
it runs, that'll work.
All right, you ready?
Yeah, toggle on, toggle off. So do y'all see his first starter come on? Yeah, I think I may have missed some of that. Try one of your overloads there. Trigger one of your motor overloads. Yeah. That made a horn come on. You're going to hear a real horn on my end. I've got a real horn.
Let's see if I can do it like this so you can see the whole thing. Let's see, I can make it.
Well, you can go a little bigger than that. That's so small. We can't see that running there.
I was going the wrong way.
Yeah.
All right.
That's fine. Yeah, that's okay. We can manage with that.
All right.
So toggle on, toggle off. Your first starter come on. Now the second one's on, and now your timer's running for the third one.
And then I hit my overload.
Oh yeah, you hit an overload and that knocked out everything. That's fine. Okay.
Yeah.
Okay, the first one's running. Second one's running. And then the third one's running. That's great. That's great. And you could put the time could be longer, but that's the 5 seconds is really enough to see it function.
Yes, sir.
And then your overload relays are fine, but I would call it motor. I would include the word overload in your tag. Because if it says motor relay, if you write the program, you know what it is. You know it's overload, but somebody coming behind you might not know it's overload. You know.
Yes, sir. Do you want me to change the my timers for the real thing to make them longer, or you may leave it at 5 seconds?
You can, five's okay. It's fine.
Okay.
If you want to lengthen them, it's okay. If you want to see it work longer, you can make them longer.
All right.
The reason I set it at 5 was because that's what it had on the original diagram.
Yeah. Mm-hmm. Yeah. In real life, what would be the determining factor on how long you set them would be you would measure the amps of the first motor. What an amp clamp? You would put an amp clamp around the leg of one of your motor leads, and when you cut the motor on, you would basically, and I'm gonna move the webcam over here to a motor. So that motor right there, when you cut that first motor on, you would measure the amps by putting the amp clamp around the lead right there, right? And when the inrush period goes down from that motor, when it starts out, the amps are going to be high for a few seconds, or it may be as high as 20 or 30 seconds, depending on what the motor's running. So when the inrush period goes up and as soon as it comes down, if you actually measure that with a stopwatch, how long does it take for the inrush period to get over with and come back down to a normal running amps like on the nameplate? Then you would set your timers according to that amount of time. So that after the inrush period is over with and the first motor settles down to a normal amp rating, you would allow the second motor to come on. And then you have a timing set for the inrush period on the second motor, and then it would allow the third one to come on, so that you don't start all of them at the same time and draw a real heavy inrush on that machine. Does that make sense? So that's how you would set. That's how you would set the timers in the program. If you go back to well, we're not looking at the one there, but at Dylan's there, but the timing between those starters would have to be, it would be set according to the inrush period of each motor. And you want to set them a little bit longer than the inrush period so that you're giving each one time to start up and level off before the next one starts. Okay. So we'll cut that off. And okay, I checked you off on that one there on Dylan.
All right, is that all I owe you, or what else do I owe you?
The TON, do you have the TON?
I'm about to make that here in a second. I ain't even started on that one, to be honest with you.
Let me check you off. Let me check you off on the emulator for the sequence control. I just did that.
All right.
Okay. So we'll move on to somebody else and see who else has a program ready. How about Jamie Jones? Is Jamie?
Yeah, go ahead, Durwood.
Hey, the answer to your question to your email.
Yeah.
Okay, you were asking, is EMI and electromagnetic induction the same thing?
Yes.
It is the same thing. That's what EMI stands for.
Yeah. Well, okay, I got you.
Yeah. The letters EMI means E is electromagnetic, and then E is electro, M is magnetic, and then the I is interference, electromagnetic interference.
Correct.
And the thing that you were saying about what does grounding have to do with helping to get rid of electromagnetic interference. Now I'll show you how it can be used to help get rid of that. Just give you a simple example here. Now do you see that speed control there?
Yeah.
That speed control has got, you know, the three leads there. That's going to be a speed control for a drive, for instance.
Right.
Now your cable for that would be a shielded cable, like this. Now the shielded cable has got, these are the three wires that would go to the pot. So that potentiometer there has three leads to it. And so the three leads would go like that. You got to have a black and a red on the outside, and a clear one is in the center. The center one is the one that gives you the variable when it leaves. That's the wiper, okay? Now, the green one here is actually, that's heat shrink that's put onto a shield. A shield that's inside of there, and there's a ground wire, a plane when it comes out that ain't got no heat shrink on it. We put some green on there so that it couldn't short out on anything else. And let me show you what that looks like before the heat shrink's put on there. So this cable has got a shield, an aluminum foil shield around all the wires to block interference from the low voltage line from the 10 volts that's across the red and the black. You got 10 volts DC that's going to be applied across that potentiometer, 10 volts. And then the middle one is going to give you from 0 volts to 10 volts as a speed control for the drive, okay?
Right.
So now, with that in mind, let's take a look at what happens when I take that cable there and I strip it back. I want you to see what happens there. I'm going to strip it just fresh right there. Now, they've got cable strippers that are a little safer than doing this. You're not running the risk on cutting internal. Let's get down closer. So you score it a little bit and you keep wiggling around. And I didn't bring the real cable strippers home. I got to kind of go around it again like that, real easy. And there's always a risk on going too far with it. So when you come apart with it, if you take a look, now do you see that aluminum foil that's in there?
Yeah.
That's a shield. Now you see the aluminum foil and a bare ground wire. You see that?
Right.
The bare ground wire is what we cover with green heat shrink. So that green there does not come. It does not come in that cable assembly. We actually add that to it We put a piece of green heat shrink around that bare wire, and then we heat it with a heat gun, and then it becomes a tight insulation like these are. This one is actually the ground wire that directs. Now, if you see the armor around all those conductors there, it's literally like aluminum foil that's conductive. That foil is in contact with that plain drain wire. They call it a drain wire throughout the whole cable. Now, so this is like a bulletproof jacket, so to speak. Okay, you see that coming off? Now that right there is the protection from electromagnetic interference on those low voltage lines. And so why do we have to have that? The reason why is because if this cable, if the wiring for this speed pot happens to be near a motor, that motor, okay, you see them motor leads right there?
Yeah.
If them motor leads in the panel, if they get near these low voltage lines right here for the speed control, this cable could easily be routed in a panel near this unknowingly by someone that wires it. Now, you got a magnetic field, a real strong magnetic field coming off of them motor leads. It's a really large, strong, super strong magnetic field. And what's going to happen is if you run a speed cable like this for speed reference near this, you're going to get a magnetic induction off of them wires into this cable through induction. Now, so if you get induction, stray inductance from this into here, what's going to happen is your clear cable here, the wire here with the 0 to 10 signal on it coming off of the pot there. Let's see here. You see the pot there? That speed pot signal, this variable on that line right there. If you get induction from a high voltage line onto a low voltage speed reference line, this can cause this to go squirrely here. So if this gets induction on it, here's what the driver's going to think. The driver's going to see this. It's going to think you're sitting there fooling around with that knob there. You see me?
So it's actually going to tamper with the signal that you're sending.
It's going to tamper with the speed signal.
Right. Okay. I got you.
It's going to tamper with it. And listen, so what you do is you have the aluminum foil. It's all around that cable there. I got it wadded up now, but it's all around on the inside, the whole length of that cable. You take that ground wire right here, and you ground it on one end of the cable. You ground it on the drive end. For instance, at the VFD itself. If I go, let's go back this way. I've actually got to move the camera. You see that power flex right there, that drive?
Right.
And when you go to wire the speed control into the terminals there for that drive, that ground right there, that ground has got to go to a ground terminal for the VFD. And you want to hook the ground up just on the VFD end only. That ground wire is going to be cut off on the pot end. So if we go back to this, right, the cable that's right here, on one end, I'm using the ground. That ground is going to go on the ground on the VFD terminals. And then on the other end here, we actually cut it off on the pot end.
Right.
So you only ground it on one end is what the book says. And so here's what happens. Inductance that gets induced that tries to bombard that cable. Magnetic energy that tries to bombard and confuse, that tries to confuse this speed signal that's on that clear line right there. What happens is when the magnetic field tries to induce there, like it's going to, the aluminum foil shield is going to block it like a bulletproof jacket, and then the energy that's kind of riding on there trying to get in is going to go to ground through this if you ground it.
Right.
If you don't ground that energy is just kind of stray floating around there, and it's not being forced to ground. So you got a risk on the ends of the cable of it. If you're just not going to have the protection unless you actually ground that.
Right, I got you.
So grounding has everything to do with reducing the effect of EMI, or electromagnetic interference. If you don't ground your protection devices, then your protection is not going to work. And kind of the way I look at it is like this. When the induction hits it, it's going to run down that drain wire, kind of like rain on a roof of a building, a house, that when it hits, it runs down the roof and it goes down the gutter to ground. So that EMI, when it hits that cable, it's going to run like running down a gutter. Down, they call it a drain wire, literally DRAIN, drain, just like a gutter drain. So this here drains the EMI to ground on the VFD end.
All right.
And so that your low voltage is protected. You know, so that's I don't mean to be so long-winded explaining all this, but when you're wiring, when you're dealing with VFDs there, I want you to look at how close the high voltage lines are to the low voltage lines. You see that?
Yeah.
So your cable has got to be dressed real short, and it's got to be grounded way up to there, so that all the way up to that blue heat shrink there, it's actually protected all the way that far. Because not far behind it, you got major magnetic field going on down here, you know. So that's a really important thing. So anyhow, so I hope that helps. You feel better about it?
Oh yeah.
Okay, good. There's a reason for everything that's in that book, those answers, and I'm really sorry that we don't have enough class time for me to have normal lectures. That's one thing I really seriously regret about this class, is that we're not getting a normal amount of lecture time in here because hours have been cut so much.
Right.
You're supposed to be getting 10 hours a week. 10 hours a week for this class. You know, that's what you're supposed to be getting. It's in the summertime, it's actually 5 hours a day, 2 days a week. But we're gonna do the best we can, you know. We're gonna do the best we can with it. And what I need everybody to do, please, when you hit something in the book that's not making sense, I want to urge you to bring it up. Please bring it up. Don't just keep going and thinking that we can't answer it. I guarantee you, I'll get you an answer to whatever your question is. I guarantee it if you just ask me.
Hey, Durwood.
Yes, sir. Mm-hmm.
Sent you the 3 motor starters, the real one?
Yes, sir. That'd be great. That way everybody can see the real thing run.
Yeah, I just sent it to you.
You just sent it? Okay.
Mm-hmm.
So look, y'all getting ready to see the real thing run with 3 starters and 3 lights in sequence and that's Roger?
Yeah.
Okay, good.
I could have swore that somebody else sent it to you before me.
I don't know. Well, I think somebody probably did. Actually, I think maybe Nathan McKee and Kenneth probably did, because I got theirs earlier, you know.
Yeah.
Let's go ahead and get yours. Okay. I'm going to start at the bottom of the list here as far as loading them, as far as saving them. So that's Justin on TON. RTO. And TOF. Okay, Justin, I got all 3 of yours. And let's see, you got also the latch. Oh, you're catching up tonight.
Yeah, I sent you everything, and then the one from tonight, the starter.
There you go. Okay, good. Save as. Okay, good. And then Roger Wilson has got the new one. Good. And then Connor, he just sent the TOF. and the RTO. Okay, I think I've got everybody. Yeah, I think that's got everybody caught up there that just recently sent emails. So does anybody remember, honestly, who's the first one that sent me, or does it matter to y'all what order we go in?
It doesn't really matter to me at all.
It doesn't matter to me either.
Who? I think you guys may have been, you guys actually sent it in the beginning of the class, didn't you?
Yes, sir.
You did. Why don't we back up to y'all and be fair about it, because I do remember getting them early on in the class, and we'll make it quick here. So we'll go through and see everybody's run, and then once I see that, then I'm going to start actually putting some bugs in this system here. We really got to do some debugging so that y'all can get some techniques down as far as using the meter and the LEDs and all that, and the computer both. So let's go. Between Kenneth and Nathan, I don't know who really the first was. I guess I'll just pick one of you, like any, mini, mighty, mo. Okay. So that's your 3-starter there. All right, and let's see. Let's go. I'm actually getting by a lot better with the audio without even using headphones. I turn my volume up on this laptop, and I'm not even using a headset. And I don't have to worry about that another cable flopping around. Okay, so let me double check your addresses here. I'm going to go a little larger here. So your stop button is good there, okay, and your alarm has not tripped yet. That monitors all three of those starters of the overloads. Start button's good. That coil's good, and that light is fine. That's your delay for starter 2. Delay done. Starter 2 coil is 2. Yellow light's 5. And then you start your other timer. Those of you that haven't written this yet, are y'all getting a good view of this?
Yeah.
This is the new one for tonight here. This is the real McCoy that runs it with real addresses. You get ready to see the real thing run to do 3 motors. All right, and then that timer is done, and then you got starter 3 comes on with a red light. And then the 3 overload relays that are the normally open side of the overload relay, they're in parallel here, 8, 9, and 10. And they're going to an alarm horn. You're going to hear a real horn go off here. I've got one wired in. And when it does, when output slot 2, output 7 comes on, look at this address here. It's local 2, output 7. That output there is actually going to shut off the starters. You see that? When that output, when the horn comes on and you hear that, this here's going to pop open and cut off starter 3. It's going to cut off starter 2. It's going to cut off all 3 starters at one time. So it's actually going to take the voltage away from the coils. So that way the Logic's actually going to be not trying to drive those starters. All right, so let's go back, and I can, let's see, I can go smaller with it. You can see everything run. Do y'all still see that? It's kind of small. I know it's real small.
I can see it fine.
Can you make it out pretty good?
Yep.
All right, I'm going to hit now the first one. In my webcam, you'll see the first one come on plus the green light, and as it goes through, 2's going to make the yellow, and then the third one will be with the red light. So you ready? So the first one's going to be instant. Oh, wait a minute. You don't have any values in the timers. You see that?
Oh yeah.
Yeah, there's no values in the timers. I didn't notice that.
I
let's go
missed
back.
that.
Okay, I can actually just put them in
Well, that's weird because I ran it on my. Well, I guess I did it on the Logic one. I put the time
on the emulator.
Yeah.
So I'm going to go in and say put 5 seconds, which would be 5,000. You can actually change the accumulated. You can change the preset right there on the fly without doing anything else. But that 5,000, the only way to get it to save it back to your laptop is to do this. Once you change it, look here, I'm going to take my mouse and go way back up here to your save icon. And when I do that, look at what it asked. The online tag values may have changed since the last upload. To ensure that the current values are saved to your laptop, you should upload them. Do you want to upload the tag values before saving the project? Yes. Now you see the green bar went across. So it actually uploaded those new settings on the timer back up to the laptop and it put them on the hard drive. Okay? So that's how you can, that's one of the few things you can actually do online right on the fly is you can change the presets on timers. Okay, so you see the whole thing now?
Yep.
Now I'm going to hit start. Now you also watch the webcam. You watch the starters and the lights too. Here you go. 1, bam. Now why did it cut off? Oh, you're missing a holding contact. Your holding contact's missing. I didn't see that.
Oh my gosh.
See there? Look.
I screwed it all up.
Look. You got a jog. Now listen, here's a lesson for you right here.
I try to do it fast.
If you don't do a holding contact, it's called jog. Look here. You're going to jog the motor. So that's good that you can see what happens with no holding contact. You see it? There's no parallel path here to keep it going once you cut it on. You let go, it just quits. So but if I actually lay on it, we can actually see your program run. So let's just do that, and then you can add it and then send it back to me.
Okay.
So y'all see, y'all follow what I'm saying? If I just keep my hand, watch my hand on the webcam, I'm going to press and hold it in, and you'll see the program run. And that is the second starter's coming on with a yellow light, and then the third one comes on shortly. So you see all 3 starters are on, and all the lights are on in the webcam. You see that?
Mm-hmm.
But as soon as I let go, it's going to quit. All that quits. If I hold it in, but I'm having to push to take the place of, he's missing a holding contact right here. Now you get number 2's on, and then 3's coming on. Bam, there it went. See it? Now, so the 5-second timing in there, as we were saying a while ago, you may have to set that to 10,000. You may have to set it to 10 seconds based on how long does it take for the inrush period of each motor to settle down to a normal nameplate amps that's listed on the nameplate. So if a motor says 10 amps on the nameplate, the startup amps could be as high as 30 or 35 amps easy, or higher. I mean, you could be 300% on startup of what the motor normally pulls. Now you can just take a stopwatch and measure how long it takes, and then you would set those timers a little bit longer than that. So that's what the timers are all about. Okay.
I just sent it to you. I just fixed it and sent it to you.
Okay. All right. Good. We'll go ahead and do that.
That's a good lesson too. Don't be in a hurry to do it before class.
Right. It's okay though. Actually, you got a chance to see something that helps you. It's sort of it shows you something that you hadn't seen yet. You would have seen it in motor controls.
Yeah.
Okay, because the program's already open. Hold on. Let's go hit OK. Let's go stop share. Let's go back. We got to go offline. Let's go offline. And then go back to the email. cannot, oh, well, let's just do something else. Copy. Now, it did this the other night, like it didn't want to let me do this. We're just going to go in and manually do it. It's being used. Huh. I guess we need to close the program then. So let's go. We're not going to shut the studio down. We're just going to actually just shut that one file completely off, like close it. So y'all see what I just did there?
Yep.
I just closed that program. I still got Studio 5000 up. So now we got to go back and get the file. Here. Save as. Now it took it. We had to actually just cut that file off completely to be able to write over the top of it. Which, yeah, that makes sense. You know, it makes sense. And then we go under open, and then it's going to be for that one. There. Okay, we're going to download again. But as y'all can see, as the programs get a little more advanced, you're seeing that your emulator it'll really show you how things run, won't it?
Mm-hmm.
It really will. It's amazing how they've got it to where to do that. And I'm really happy that and thankful that we've got it that we can use. So let's go back over this way and back out one. Now, do y'all see the whole program?
Yeah.
I'm gonna hit start. So the first one came on, and now it's got a timer starting. When it finishes, the next one comes on. Now it's got another timer going on. It's gonna trigger this one. Bam, there it went. Now that's not a whole lot of delay in there. You can make them longer, but you see it in the webcam. Yeah, all of those came on. You got all those lights on, right? So again, we can set them timers longer. In real life, they probably would be longer. Now here's your diagnostic thing here, your safeties. So watch closely. You see my hand moving in the camera here?
Yep.
Now watch. I'm going to come down here and open up the door, and I'm going to trigger the overload for number one. Now listen and watch. Okay, something's wrong. Something's wrong with the program. Oh, I see what's wrong. It's your addresses. Your addresses are actually outputs, not inputs. You got to be going to the inputs, not outputs.
Oh
you
my
see that?
gosh. Yeah. And you know what's so bad? I like treated myself to a thing of cookies because I was like, man, I finished that before class. and I didn't even deserve it.
But what you want, if you look into webcam, you see those new normally opens that are in the picture there.
Yep.
It's actually slot 1, I, and then 8, 9, 10. So they have to, but they're physical inputs.
Okay.
Yep, instead of outputs. Okay. So what it is down here, you're not really monitoring your overloads at all there. Yeah. Okay. So we'll cut this off, and it won't take you but a minute to fix it. You can just send it again. So it's all good. It's all good lessons that we're learning here. You know. So hit stop. So anyway, you see the local 2 and then the O. It's supposed to be local 1I. You know. So we'll. Let's see.
That's why you should never volunteer to go first.
Right. We'll click on and go to Kenneth. We'll check Kenneth.
Why do you think I waited?
Oh.
Whenever you get a chance, Durwood, I got my emulator ready. I'm working on the Logix now.
Okay. All right. Right. Let me go ahead. Kenneth had sent his at the beginning of the class. I'm gonna try to, as best I can, try to catch who was first. And I tell you, y'all need to help me with this, because I know there's no way for me to really remember it completely, who was first and all that.
Input.
So this is what program? What program is it, Kenneth?
It should be under sequence control.
Okay, SEQ Real.
That's it.
It says it's not recognized as a valid project file.
I don't know why it sent you 2 of them, but it's an ACD. Let me send it to you again.
It says it's not recognized as a valid file. There's something about that file that don't like it. I don't know what it is.
Remember, it sent 2 of them in the email.
Right, it did, yeah. All right, let me just actually hit delete on that one. And let's go back to the email. And I don't remember which one I picked, but I'll just try. Do y'all remember which one I got, the left one or the right one? I don't remember.
I think it was the left one first.
All right, let's try this one. Okay. Stop share, go back. And let's go to open.
Let's see.
It opened that one. It liked that one. So the other one was something. Yeah, the other one, something was wrong with it.
My computer's been thinking.
Could it be that you selected multiple files by accident?
Did what?
I said, could it have been he selected multiple files by accident to upload? I just thought.
Yeah, I don't know. I really don't know what happened. The file names were identical. You hear that alarm?
Yes, sir.
That's where I already had it tripped from before. Now, when I hit the blue button, it's going to clear it. You hear it go away?
Yes, sir.
I had it tripped from a while ago on Nathan's. Okay, so let's run yours, and then I'll trip an input. So we'll back out. Okay, do y'all see the whole thing?
Yes, sir.
Yeah.
All right, we're going to start the first one. I went the first one. You see the green light, and the first timer's timing. The second one, here comes the second one. Second timer's timing, and now the third one come on. So we'll trip them one at a time, and then run again. So I'm going here. You see what I'm doing at the bottom here? I'm opening that door up, and now I'm going to simulate a trip on motor 1. There it went. So if you look at the logic, do you see the motor 1 overload relay is green down here?
Yeah.
Yes, sir.
That's green, and then output slot 2, output 7 is on. And when it went on, look at what happened here. This contact that examined off, it actually popped open. See it?
Yes, sir.
And then also this in here popped open. So when these opened up, because the output 7 came on, then it made what looks like normally closed become open. So that address had to become active, true, and then it made that be false, which cut off starter 3, it cut off starter 2, and it cut off starter 1.
Sir.
And now, if you watch my hand in the screen here, I'm coming down here at the bottom. Now, when I hit the blue button down here, and let's come on down this way further. You see my hand going to the blue button?
Yes, sir.
Yes,
I
sir.
pressed it. When I pressed it, you see what happened on the screen?
Mm-hmm. I can hear it too.
You can hear it. All of a sudden, the overload contact, the normally open coming on the input 8, that went away. Output 7 cut off. And when output 7 cut off, it allowed those examine offs to actually go back to their normally closed state. So these that look like normally closed, they're going to stay that way as long as output 7 down here is not on. Now, when output 7 comes on, I'm going to trigger another one. So if I go in here, if you can watch closely here what I'm doing, I'm popping open door 2 on starter 2. Now watch. I flip it over. You see it happen?
Yes, sir.
You see in the program that the motor number 2 is actually lit now. The overload's lit. You see it?
Yes, sir.
Now, while it's lit, look at what happens if I try to run it. I hit the start button. You see me hit the start button up top?
Yes, sir.
Nothing's happening, is it?
Not at all.
Because you got an alarm condition here, and so what do I do? How do I clear the fault?
Reset the alarm or reset
I hit the blue button. Bam! There it went. So this is how you interface overload relays with a PLC input, so that you've got a true interface. You've got a two-way interface. You have the PLC is telling the coil to come on the starter, and then the overload is telling the PLC either go ahead and run or kill it. So the starter, it receives a signal to the coil, and then the overload relay is a watchdog for that tells the PLC, it's okay to run or it ain't, So this is the way it's supposed to be done here as far as the interface back to the PLC. That makes sense?
Yes, sir.
Yep. And you can also interface VFDs that way. Those the PowerFlex drives, they got contacts on them, relay contacts that can interface back to a PLC also to tell you if it's faulted or not. So, all right, so that's good. How you feel about it, Kenneth?
I'm pretty comfortable with it now.
Yes, sir. Yes, sir. Yep. Okay. So you're getting to find out here that this you can do honestly, and you're just getting your feet wet with it now. You're not even really you might be ankle deep right now. I'd say you're probably ankle deep, but you're definitely not knee deep in it yet. There's a whole lot you can do as you're finding out that the possibilities are really great. So I just checked you off on that, and let's see who's next. Let's see.
I got my emulator ready too, if you want to see that.
Okay. All right. Go ahead.
Oh.
Okay. Good. Isn't that amazing how you can run it right there with no real PLC? Isn't that amazing?
Oh yeah.
It really is. Right. He's going to trip overload. Bam, he did that. The horn come on and it cut everything off. See that? So you really can do a very good test on Logix with that emulator. And that's why I want you to see it on your programs, that for development reasons, you guys can, even if you ain't got a real machine to tie to at the moment, you can really start creating stuff on your own, even beyond this class. As long as that 90 days ain't run out, you can keep creating Logix and experimenting on your own. And if you want to pay Rockwell to keep it on, then you can do that, or your employer can do that. So, all right, so I got you there. And Nathan, did you send your other one?
Yeah, I sent the corrected one.
Okay. Let's see. Okay, so right there, we'll skip the other one. Save as, and let's go here. Save. Yep, go there. And stop share, and there. I'll be glad to get that other webcam in. They sent me an email a few days ago saying that they discovered a very good webcam that's really great for small print, called a document cam, and so they've ordered. I said, get me one. So, you know.
Yeah, I told them to give me one for me and one for the other instructor.
Mm-hmm. Yep.
Anytime they're gonna give out free stuff, I take it. They
right.
ask about headsets too.
Yeah, they did. Yeah.
And the headset they're getting is the one I'm using right now, which works pretty good.
Mm-hmm.
Well, hurt to have backup.
That means you'll have a spare.
Yep.
That's right. You don't never know when one may go bad. You know, you may
because technically the one I have right now is my wife's. This isn't a school headset. So I can give it back to her.
Right.
The earbuds I'm using right now, I need to get a new set because my right earbud went out. Now I'm using the left one. I need to think about going to Best Buy, but I think they're closed, right?
Probably now.
Yeah.
Let's see. Where's my mouse at? Right here. All right. Now you see the whole thing?
Yep.
Okay, let's check. Your addresses is slot 1I 8 9 and 10. That's good. You'll be fine. Here we go. 1 2 3. Bam. There. That's right. So you see the green light, and you hear the clicks. There goes 2. Exactly. Now let's trip it. Let's get us one trip here. We'll trip number 1. There it went. Yes, sir. Cut everything off. Clear it. Exactly. Start it again. I'm going to trip 2 in the middle of all this. There went 2. Start it again. Then we'll trip 3. Well, let's let 3 run and then I'll trip it. There it went. Perfect. The stop button don't cut it off. You got to clear the fault with the actual overload reset button. Yeah. Yeah. That's good right there. That's good. Okay.
You want me to share my screen and show you my Logix?
Mm-hmm. Yeah.
All right.
Let's see. Nathan.
Can you see my screen?
Yes, sir.
All right. So I'm gonna go who active.
So is there a physical reset button?
Yeah.
So it doesn't have to be programmed. Gotcha.
See right there, that blue button right there?
Oh, gotcha. Yeah.
Right there, right on the overload relay, that blue button. You got a blue button and a red one?
Yeah, I just want to make sure I wasn't missing anything.
Yeah.
Are you ready?
The blue one says reset, and then the red one is actually a momentary trip. If I hold the red one in, it'll trip it momentarily, but it'll clear itself. If I open the window and slide the window over, it actually is a permanent trip, you know. It'll stay tripped until I reset it. It's like a real test condition, you know. Okay, yeah, go ahead.
All right, so starting it.
Good.
Toggle this off.
Right. And the second one's on. Good. It's amazing to me that you can sit there and run Logix like that. That's perfect. And then trip one, bam, there it went. You can really do a lot of development like this. I mean, a lot. You can really do a lot of debugging instead of debugging with real equipment. That's a good thing, you know.
Yep.
To be honest, it fits right in so well. It feels like it's part of the program.
Oh, yes, sir. Yeah.
All righty. Can I go next for the real logic?
You go right ahead. Whoever speaks up can go.
For the real logic, the 3 motor starters I sent it to you.
Yeah. Okay. Okay. Well, I'll tell you what, I am glad, very thankful that we've got what we've got at our fingertips. Because if it weren't for all of this, you know, the first time I was told that we were going to have to do this online, I was not happy. I was not happy, fellas, I'm telling you. Until I talked with Rockwell. Well, the first thing that got me feeling better was when I found out about Zoom. I said, well, that'll really help a lot. And then when I talked to Rockwell, then I felt right good bit better then, you know, a lot better. Okay. So start. There was one. Yeah, if y'all watching in the webcam, you're seeing the lights and the starter here, the clicks. There's 2. 3, perfect. And now let's trip them. So his first one, there it went. And you see the logic, y'all watching the logic, how it responds?
Yeah,
that overload relay is sending an input that's causing this, okay? Clear? So this is the way, if you take full advantage of an overload relay, then you'll interface it. There it went. You can also have the PLC to put a message on a screen, on a panel view screen. That's something I'm going to introduce to you toward the end of this class. Is a HMI. A HMI is it's a screen that'll be on the machine that you can put messages on. You can actually let the HMI, the touch screen, replace a lot of what's on the buttons here. The only thing that it would not replace would be an e-stop. The e-stop, you don't never replace that. But you could actually have all these switches and buttons actually put onto a touch screen where there's no physical button there. And then the screen could also give you messages and say, motor starter 3 is the one that tripped out. So it can tell the operator specifics on what went wrong. If you write enough logic for it to give you messages to store them in there, you can have that input to trigger a message and it'll shoot up on that screen and tell the operator, go to pump number 3. And it saves a lot of time. You don't have to figure out which one went out when there's a lot of noise going on in the room, you know. So that's good. Okay, so I'm gonna put you down for that, Roger. That's good. Very good. Okay, did a nice job there. Now, how do you feel about all of it now? You're getting really good at this stuff, aren't you?
Yeah, I understand. I understand it now.
Yep, very, very good. Yeah, when you see something like this, you're getting the idea how would you make an automated machine work. You do it with a series of timers and a series of inputs and conditions, you know, and you can make something sequence like on our automation system at school. So, okay.
Yeah.
Who else wants to get checked? because I've lost track of really who was next and all.
I sent you all mine. This is Justin.
Okay, good. Okay, so let's see his. There. Let's go here. So let's see what do I not have? Let's see.
I think starting with the latch, unlatch. I know you haven't seen that one.
Okay, let's see.
I think that's the oldest
Okay.
one.
All right, I was checking my grade sheet here. There you go. Lord, I didn't mean to do that. Well, I just did something really wacky there. Y'all see what I did? I floated my controller organizer. That's not good. I'm getting too big of a hurry there. Now, why did it do that?
I think you got to set that to dock.
You didn't put it all the way over.
Controller.
It wasn't fully connected. I think it was still covering up stuff.
Mm-hmm. There it went. That was good. Thank you, Justin. Okay, now we go to.
I only do because I've done that about 1 million times so far. I actually X'd out of it one time a few weeks ago, and it took me
I forgot.
half an hour to figure
about
out how to get it back on.
Yeah, I forgot about the dock feature. Now I forgot all about that. Yeah.
Hey, don't worry, mine's still messed up from whenever I messed up that first time. I haven't fixed it yet.
That knowledge, unfortunately, came from experience. So.
Yes.
All right. How do I download it, Justin?
Go to Communications, Who Active, and then click on the Ethernet, and then the actual link there, and then download.
Good. So how long from now do you think it'll be before you start on your degree at UNC Charlotte, Justin? That 4-year degree.
Well, I'm gonna finish up at ECU, so I'm gonna start it next summer.
Next summer. Yeah,
because their program, their distance education program, for some reason starts in the summer.
Okay.
Which is odd, but.
Mm-hmm. Okay. Yeah. Okay, so we're gonna hit our latch. That's good. And did you see the other night when we powered the system down how it remembered the latch state?
Yes.
Okay. And it hit unlatch. Perfect. So that's very good. That's it. Okay, let me check you off on that. Let's see, latch. Okay, gotcha.
Hey, Durwood.
Yeah.
Hey, I sent you my sequence one, and I'm ready for my emulator whenever you're ready.
Okay. Let me finish up here with Justin. You say, give me a shout when we finish up with Justin here.
Okay.
Give me a woo, and
all right.
Say yo, don't forget me. All right. So TON. Okay, start button. Timing good. That's it. You see it, you hear it.
Sir.
And we'll hit stop. That'll clear it, and it's ready for another run. That's good. Okay, so that's got you on TON. All right, good. TOF. Well, Justin, the school that you were going to, where you took electronics in Jacksonville, do they have it? Do they have any PLCs down there?
We didn't do any at all. I don't know if any other program does. I don't think so.
You don't think they do?
I mean, it wasn't, you know, full-fledged PLCs. We did programming, you know, on a smaller scale. That was pretty much the same thing, but it wasn't, you know, wiring up full-fledged PLC stuff.
Mm-hmm. Okay, I'm gonna hit start now. Your fan's gonna come on instant now, and then when I hit off, then it starts timing, and you get a post delay there for a cool down. Yeah. What happened with me, Justin, is when I got the degree that you got, the electronics engineering. When I tried to get work, I couldn't find a job doing just electronics. It was hard to find back in 1986, a long time ago, over 30 years ago. And so I ended up getting in industrial controls. They hired me because I had an electronics degree, but to use it with the industrial, not just on component level like what we learned, but doing it more on system level, you know.
I got you.
And learning it, and then that's how I found work. So that's why I've stayed in industrial controls all these years, and got more heavier into PLCs.
I got
So
you.
I went where the opportunity was. I mean, I went to Raleigh, Charlotte, Fayetteville looking work. Couldn't get in. The competition was way too much. You know, I would apply for a job beside somebody that had a 4-year degree and 10 years of experience, and me here I was with a two-year engineering degree, 2-year engineering degree in electronics and no experience. And me in a big town like Charlotte or somewhere, you know, I'm trying to get work, and it just didn't work. So I come back home and, you know, got into Fujicon, and it really worked out really for the better. For me, you know, based on where I'm living at, you know.
Yeah. See, around here we got the base, and then we got Camp Lejeune and Cherry Point. So they hire everybody up, right up. You know, they want component level stuff. So like working on aircraft.
That's good. That's good. That's real good. Yeah. See, I didn't really have a opportunity to do it, or else I would have done it. You know.
Oh yeah.
Yeah. The doors. I just said it's not meant to be, evidently. You know.
And I actually before I graduated there from Coastal, I had already got hired for a company. They're called NWL. They make like metal film and capacitors, like large scale industrial capacitors and stuff.
Mm-hmm. Yeah.
They're out of Snow Hill.
Yeah.
And I drove an hour and a half one way, worked 10-hour shifts for a while.
Yeah.
About killed me.
Yeah, that's too much. Okay, I hit start. There it goes. You see it running?
I do.
Hit stop. It saves it. Start again. Let it finish. That job I went for in Charlotte back in '86, I drove 4 hours to go on the interview, and I placed about a 93 or so on an entrance test. But I met a guy right beside of me, had a 4-year degree and a 10 years experience. He had been laid off of somewhere, and
yeah.
Anyway, so I hit
hard to compete with that with this in the same field.
Right. Now I'm gonna hit the reset button, input 7, and it cleared that. So that's good. Yeah.
See, when I got hired out there at NWL, they actually hired me over a 4-year degree guy because I had an electronics degree. And the other guy that they were considering had a 4-year degree, but it wasn't in electronics. So they hired me over him.
Yep. Because you had more, you had component level understanding there.
Yep.
Okay. And then you also did your other one, your sequence control.
Yes, sir.
What exactly is component level understanding? Is that like the parts of the PLC?
Well, basically it's like this. Is if you open up a computer and look at a motherboard and see all the little small components on there, resistors and integrated circuits and capacitors, getting on the inside of the PLC and actually repairing the boards, repairing the inside of the modules.
Oh, gotcha. Instead of just replacing them.
Instead of just replacing them, actually going into them and fixing them. Yeah.
Okay.
So it's a world of its own, and it's there's not much of that going on around Sampson County. Very little, almost none of that would be going on around here. There's not time because production demands are so high. You gotta trade something. You gotta trade something out and keep going. Yeah. If
a lot of our machines, because we had a lot of government contracts and everything was custom made and designed. So me and another guy that actually went to Lenore Community College, we pretty much built all the machines in the plant and the meters and stuff. So we really got to do a lot of cool stuff and blow stuff up. And
hey, Durwood, for the expansion module, are we gonna change this to version 3?
Yeah, 3.1.
I just want to make sure.
Yep. I didn't have that note on that last schematic. I see that now. I missed that. Yep, I overlooked that. I need to add. I'm gonna pencil it in red here. That last diagram I sent y'all, the schematic I emailed you for module slot 2. You want to put firmware version 3.1, revision 3.1. So just like always. Yeah, I forgot. Okay, so you see your program?
Yes, sir.
Start. There goes 1, 2, 3. That's good. Let's check your overloads. Good. Start again. Good. Start them again. And I could just trip it premature. That's going to cut everything off. That's good. Very good. Does it make sense what you're seeing?
It does.
Good. Great. Okay. Let me put you down for that. So that's got you for the real McCoy there. Great. Okay. Now let's see who else we can check.
You ready, Durwood?
Yes, sir.
You want to do the emulator first, or you want to do the Logix first?
Go ahead and do the emulator. Yeah, I want to see the emulator. It's important that you see it run, that you actually run it yourself.
Right.
That's one of the things that really makes it as real as it can get for a remote class, is you having an emulator there. And I can just tell you from experience that even where you're working at, even though they might not let you get your hands on it immediately, at some point down the road, when they find out what you know, it's likely that you'll get a chance to use it. You know, that's what happened with me.
Right.
Now, the first time I worked, go ahead.
Mr. Durwood.
Yeah.
We just put 2 brand new escalators in, and they I was the one that had to program the variable drives for those.
I missed part of what you said.
So at Schiller, we got 2 new escalators for the lobby, like actual ones that could be running 24/7.
Uh-huh.
And they actually let me wire the drives to those and the motor and all that. So the whole shebang, pretty much.
Good, great.
It's a new model we have now. Oh crap! I'm about to die.
That's good. So they're trusting you good. You okay? Go ahead and trigger it. Okay, something.
I cut it back off.
Well, you have it. You're not online.
Oh, that's right.
You got to download and go online.
Yeah, that's because I had it up there one time and forgot. Oops, what am I doing here?
Just X out of that.
Yeah, I am.
And just hit your escape button. Hit the escape button on the keyboard. There you go. Mm-hmm.
I'll move this out my way.
Yeah, you need to toggle that start button off. What it is, you already had some stuff toggled when you downloaded it, so
yeah,
it's just kind of locked up right now. Now toggle the stop button off and let it reset. Now let it come back on. Now toggle on, toggle off. Perfect, that's it. Yes, sir. Perfect. Okay, now trip one of your overloads. Oh yes, sir. You see that?
Mm-hmm.
Isn't that amazing that you guys can do this right there with an emulator, and it does the same thing as it does on a real one? Isn't that amazing?
Yes, sir.
It is to me. I mean, it really is. I mean,
It is.
It's really great. Yeah.
I sent you my Logix too, the PLC one.
Okay. All right, let's go ahead and check it. Yeah, it's some. I've been knowing about emulators a lot of years, but I've never really had a reason to use them because, again, I've always had a real one to use. Let's see. Jamie just sent one. Hey, Jamie, is he still in?
As far as I know, he is.
Yeah, he's in.
Yeah, I'm still in.
Yeah.
I'm fixing to send you the
real one. Yeah, you're sending the real one. Yeah, the emulator. I want to see you run the emulator. Yeah.
Okay.
Yeah, I would a whole lot rather see you run that.
All right.
Let me go back to my email. Okay, so yeah, the emulator. I'd rather see you run that. Eric, there goes Eric. Yeah. Back. That's good. And then Benjamin is also sending the sequence control. Very good. I think that's got us caught up on email there. I believe it has. Connor. I think that might be new there on Connor. I don't remember for sure if I saved those or not.
Connor said he thinks he did, but yeah, I think I'm actually about.
I sure did. It just showed me right there. I had already done it.
And I'm about to email you. I'm attaching the files now. My 3 timers.
Okay, good, good. Yeah, I was wondering when I was going to hear your voice pop up there.
Yeah, I've been doing mine.
Yeah, he's been doing his.
All right, so we're checking Eric's
Yes.
real sequence.
Yes, sir.
Okay. All right, you see your program?
Yes, sir.
Okay. So hit start. Now, this is, hey, everybody, y'all listen, tell me what's wrong with this picture.
It's not staying on.
Right. Whoever gets it gets a plate of fish.
Is the motor starter one cool? I think.
The branches are on the wrong contact.
Yeah. Y'all see that?
Oh, yeah, I did.
The holding contact is in parallel with the alarm contact.
Yeah, I should put it under the start. Yep. I got you.
Hey, you get the Picasso Award. I used to call the guys at the shop if they did something just totally unique.
I think I got that one.
I call it the Picasso Award. I
don't remember what I did, but I remember getting it.
Yeah, I think you got it before in motor controls. Yeah.
No, it was in residential wiring.
In residential, you did something completely original.
Yeah,
it really got my attention.
It was. I think it was crazy. Whatever I did, I'm probably.
It was because you got that Picasso Award that day.
Yeah.
Does everybody see what's going on there? When I hit the start button, it's the branch is around the wrong thing. It's supposed to be around. It's supposed to be around the start button, not around the alarm. So that's pretty original. Right, so I'm gonna
I'm fixing it right now, Durwood.
Okay. Let's take a look at everything else while we're at it.
That's a simple fix.
It is, yeah. Starter 2, yellow light, and then good. Yeah, the rest of it looks fine.
Yeah, I must have fell asleep on that one. Something happened.
Well, it's a part of learning. You're doing really, really great from that. You don't really have a background in plants, do you? As far as not really working with stuff.
Nah, not really.
So you got a good head for it for sure, or you wouldn't be hanging in there like you are right now. I told Ronnie. I said, Ronnie, you got you another Jamie right there.
I don't know if I ever line up to Jamie. Yeah. I'm trying.
Yeah.
It ain't easy, son. It ain't easy.
I know.
Yeah. Okay. So while you're working on it, let's see who else we can take a look at.
All right.
I just emailed you all of my 3 timers, and you've got Connor's too. So I reckon we're ready whenever.
Okay, let's go back to email. Okay, so that was Jamie. So is this the new one, Jamie?
Yes, sir. That's the ladder diagram.
That's the new one there, sequence control. Okay. All right. And then Cameron sent one. All three.
Yep.
Okay, good. Okay. So if I check them in the order they came in, Cameron, yours came in a little bit about 2 minutes ahead of Jamie there. Let's go and let's see. Go back. I wonder why I'm missing all the rest of that organizer. I think I clicked something I shouldn't have been clicking. I've done something over here. I'm not sure what it was, but anyway.
Well, maybe as long as it works.
Okay, Cameron, how do I download it?
AB Ethernet. Click that. Yeah, and then the long number there. Or module, my bad. And then download again.
Well, Cameron and Connor, what do you guys think about this class compared to ELC 215 now that you're getting the right logic?
The 215 class definitely helped us start an understanding of the PLC basics of using it. And this
Yep.
just shows how to make it.
Yeah, you're more on the engineering level now instead of just troubleshooting a pre-made system. All right, start button.
Yeah.
Yeah.
You see it running?
Mm-hmm.
Now what you just saw right there is there's a whole lot of timers in every station on our SMC system at school. Every motion on that system that's staggered by time is controlled by these timers like this. And you know, those were in there. I don't know if you remember seeing many of them in the program, but they were scattered all throughout. Every station had a lot of these timers in them. And anyway, so that's good. Hit off. That's it. That's very good. All right, so that's Cameron.
All right, Durwood, I sent you my new one.
Okay. Connor, did we see your on delay timer? I've actually got right. I actually checked. I put down that I actually checked Cameron the other night on this on delay.
No, you checked me.
Okay.
Yeah, you checked one ahead, not the other
You
two.
checked my own delay, but that's it.
Okay, so I put the check mark on the wrong brother there. Okay. All right.
Yeah.
So let's go back. I thought something was wrong there. Well, my paper's everything's kind of scrunched up. My spreadsheet is really small.
Oh, yeah.
I don't know what happened to the rest of the controller organizer. I think I clicked something by mistake a while ago.
All you gotta do is go to the bottom right there. 'Cause I did that earlier. You got logical organizer and controller organizer. You probably got on logical. You see where I'm talking about, Durwood?
Well, no, I don't.
right there where your control organizer usually is, go all the way to the bottom.
At the bottom?
Yeah, it's on the bottom left-hand side.
Look, I think mine's being covered up by something else.
It might be. That's what I did earlier. I hit Logic Organizer, and that's what I got, what you're seeing now. So I had to hit back Controller Organizer.
Logical. Yeah, I see that, but it says logical. But I don't see a way of changing it.
It should be down there at the bottom. I don't know why yours ain't like that.
It's covered up by my by something.
Oh, by your errors. I don't know where yours went.
Well, it's actually behind. It's actually behind a blue bar.
Yeah.
I ain't gonna worry about it right now. Cause I don't have to have the rest. At the moment, I don't have to have that.
I'm trying to figure out how you did that.
Yeah, I can't see the buttons right now. I just go. Yeah, we won't worry about that. I'm not gonna kill up time on that right now. So I'm gonna hit the start button on yours, Cameron, and the starter comes on right now because it's an off delay. And accumulator is 0, and when I hit the stop button, it's when it begins to time it. It's gonna hold it for a while. See that? So it would be like for a cool down fan or something like that, for instance. That's good. I don't know if y'all have any use for that, like on the farms or not.
Not that I'm aware of.
Off delay.
Hey, Durwood.
Yeah.
I figured out. Go to where it says View on the top left hand, where it says File, Edit, View. You see that?
I just seen that. That was good there.
All right.
I was thinking about going into View later on and going and trying to find something in there, but I've never had that happen. Where you couldn't see all of your I/O and your Ethernet. That was not a good thing there.
You might have closed it out. That's how I tried it just now. Close it out and see what would happen.
Yeah. Okay, so we're good to go there, and so that your TOF is good. I got that, Cameron.
One more.
RTO. All right, start button. Hit stop, and it holds that time. You see how it keeps it?
Yeah.
Did you see the other night whenever we powered it off and it kept the time?
Yeah, we did.
Okay. If I hit stop, that doesn't clear it until I hit the reset input. There you go. That's it. That's good.
Sweet. Oh, yeah. Would you like to go ahead and set counters too?
Yep. Yeah, go ahead.
All right.
Let's go.
Yep.
So we're going to check his TOF.
TOF and RTO. Yep.
Excuse me. Okay, hit start.
Yep.
That was the instant on for a fan. Hit stop. Then your timing starts.
Yep.
That's it. Very good.
Yep.
Okay, RTO. Well, okay. Okay, RTO, here we go. Start. Stop. And it remembers it. See that? Let it roll. Hit stop, and it still doesn't clear it until you actually physically reset it. That's it. Very good.
All right.
Okay. Is that everything you have sent me?
Yeah. I have my 3 emulators down for the timers too, but I haven't restarted the computer, so my emulator for whatever reason.
Yeah, we're better off really moving on and letting some other people just whenever. Yeah. Let's just try that the next go around.
All right.
And that way you can okay. So
Durwood, you want to go back? Do you want to go back to mine now that I sent you the new one?
Yeah. Yeah. Okay. Now, while I'm looking down the list here, is Mason Cottle doing okay out there?
I'm pretty far behind right now. I'm working on it though.
You are?
Yes, sir.
Okay. All right. Well, just speak up when you get ready to
Y'all just helping him out.
Yeah, just speak up. Don't let us crowd you out there, okay?
Yes, sir. I was gonna ask you to help me with it when we get close to the end, if you don't mind.
Are you where you got something you're working on right now? Were you kind of?
I'm trying to download the sump pump one, and it keeps saying that my controller slot's not in the right spot.
Okay, do a screen share. Let's try to get you over the hump with this.
All right.
And then we'll go right back to Eric, okay?
Sounds good.
Yeah.
You see that?
Well, for one thing, you got real addresses in it. You can't put real addresses in the emulator.
Oh, that is a problem.
That's a big problem. You got to use just base tags on the emulator.
Mm-hmm. Okay.
Do you have another version of it with just base tags?
I don't, but I can make one really quick. If you want to go ahead and do Eric, I can work on that.
The version you have right there is actually very close
to you, correct?
Yeah, it's close to it. That's assuming now let's double check and see what kind of controller did you use. Go over in your organizer at the top of it where it says controller sump pump real.
Mm-hmm.
And right click on your properties. Let's find out what kind of controller you're using. So you're using a real PLC there.
Yeah.
So you need to listen, keep this for regular. Keep this for the real thing.
All right.
Matter of fact, why don't you just go ahead and finish up the real thing?
Well, I had it finished. I don't know why it's got question marks under that now, but yeah, I'll get it done.
Well, because look, you didn't really finish the tag over there on the coil.
Uh-huh.
If you right click on that, let's look at the properties. Yeah.
Properties.
Yeah, edit the properties. Yeah, that's right. Okay, that's actually good there.
Yeah, I don't know why it's got the question marks.
It's an alias tag. Oh, because you haven't added your expansion module for slot 2.
Expansion model for slot 2. Where you do that at?
Over the controller organizer.
Okay. I hit okay for this?
Yeah. You right click on, you got to add a module. That's what's wrong there.
I did that a while ago. I don't know. I think I changed it and it changed some stuff. I changed the controller or whatever it was. It's OW16, correct?
That's it. And you give it a name, you can just say relay output. It's got 16 relay outputs.
I changed this to 3.
That's right. Yep. Yeah. You got to hit OK. And now hit close.
All right. Now I can send you this.
Well.
Or.
Yeah. You hit the save button and send it on. Yeah.
All right.
Yep. Exactly.
Okay.
Yep.
Yeah, I have to open up my email in a second.
But that's exactly right. Yep.
If you want
to go ahead.
If you just want to do Eric, I'll go ahead and send that to you.
We'll do that. Yeah. Yep. Yeah. If anybody's hit a stopping point, don't hesitate to say something because we want to help everybody kind of get even out. Okay. I see Darren's coming in. Yeah, I was wondering where Darren and Justin was. I was getting ready to send the sheriff after them. Yeah, they're watching.
It wouldn't be the first time that happened.
Huh?
It wouldn't be the first time he'd been there.
Oh, Lord.
Question for everybody. Is anybody else in the OSHA safety class?
Yeah.
Do you know when the class is supposed to end?
No.
Because those assignments look.
He just started grading the stuff today.
Yeah, I know, because I've sort of kind of been slack on them turn-in assignments. I need to get them done.
Yeah, he just graded module 1 today.
Okay, so he hasn't done module 2 or any of that?
But all the quizzes should have been done by now. Last night was the last time on module 4.
I already did all the quizzes.
Okay.
I just want to make sure I wasn't too far behind.
Nah, he's just grading, like I said, all the assignments.
All right.
Okay, so we were going to go back and check Eric's, right?
Yes, sir. Did you get the other one out the email?
Well, that's kind of what I'm wondering. I don't know. I don't remember. Let's go back.
I don't think you did yet.
I don't think it did either, because you had to fix it.
Yeah. So I sent you a second one.
There you go.
Yep.
I see another one from Jamie too.
Jamie trying to climb that ladder.
Okay, and let's get Jamie's while we're at it. And okay, so I think, okay, there goes Mason on sump pump. Okay, good. I think we're caught up there. Let's go back. Go back to here. Now, so it's Eric that we're checking now.
Yes, sir.
Y'all help me now. Help me keep this thing straight on in the center of the highway here.
Go back up. You bypassed me. There you go.
Yeah, I need a fish plate. It's getting close to Friday. Yeah, it ain't but Tuesday, and I'm needing another plate to play fish. So
The 844 one. Go down.
let's see. Sequence control.
The 844 time. There you go.
Right. I'm hearing crickets.
Probably me sitting out in this parking lot.
Yeah, do y'all hear a cricket real loud? I the only one to hear
Thinking that was outside.
as much as rain we've had lately.
Yeah, I hear them crickets are pretty loud. They're getting.
Oh, I can hear it. I can hear them right outside where I'm at too. That was muted, so couldn't have been me.
Okay, so we're gonna hit start. There went the first one. Y'all watching in the screen, in the camera, you see the lights.
Mm-hmm.
Number 2, and a yellow light. Okay, now this is okay. Troubleshooting time. Everybody, get your thinking cap on. What's wrong with this picture here?
Hold on, I'm trying to figure it out now.
This is good.
He's got a. No, that's not it. Never mind.
Maybe from home start D3. Copied all that, right?
Got a normally open where it should be a normally closed on the.
Oh yeah, yep, right there. Yep, right there.
Kenneth gets a fish plate.
Jesus. I'm having a hard time over here with this. The world.
It was bad. I was in troubleshooting class too. I didn't
Let me
see
just listen. Let me just tell you. I've seen engineers go through the same debug process. It ain't no different. I'm serious.
Oh, I believe you.
I've seen some real doozies, man. That system we got at the school, the automation system that was built, SMC built it. We went through, there were numerous software glitches in that system that were some of them were plumb hilarious. Some of the stuff that would happen on that system that were PLC logic errors in the way they had their logic written. And I would actually take a picture or do a short little video thing of what would happen physically on the machine because of a software error, a logic bug, and send it to them, and they would say, well, we apologize, and they would fix it and send me another program, email me another program. I download it, and then it would fix that one, and then it would seem like I'd find another one. I went through that maybe about 4 times with different bugs in a system that was built by a major worldwide company, you know. So
right.
Everybody debugs, man. I mean, honestly, if nobody does, they're probably lying to you, you know. So we're gonna let you fix that, and then you send it back.
It's already fixed. It's about to send your way now.
Okay.
That was an easy fix compared
Right.
to the last one.
But everybody debugs. We all debug. We debug in our own personal life, and we debug in our programming, right? So life is like that's just a part of life, ain't it?
Yes, sir.
It is. Debug.
All right, sending your way.
Okay.
You should get it in a split second.
And this is even amazing here that you're sending me an email through Wi-Fi at Hogslat. You're only 3/4 of a mile from my house. And you're sending it through the plant Wi-Fi. It's going out, and then it came through my. It went.
Yeah, I heard it.
It went around the elbow to get to the thumb, didn't it?
Yeah. I think I got it this time.
Now it won't let me save it until I actually
delete one.
Well, I've got to go into program and actually close the file.
Oh.
So even though I've just got it on offline, you got to go into file and hit close that file, so that I don't have it open. The file was open even though it was offline, you know.
Right.
So you have to completely close the file to be able to replace it. Which is perfect, makes perfect sense when you think about it.
Yeah.
You can't copy over something that you have open, you know.
Yeah.
Now it let it. Now you see the difference there.
Yep.
Yeah, it knows if you got it open. It's not going to be rude to paste over the top of it. You know what I mean?
Right.
It would be it just wouldn't work. Yeah. So.
I think we got this time. Yeah. Now we got all the green lights showing.
Right. Yeah. Okay.
I don't know why I didn't see that the first time.
Right. Well, it's just, like I said, we all debug. The best of the best debugs. Just remember that. You know.
Oh yeah.
Every engineer I've ever worked with that wrote programs or did electrical design, all of them debug. Everyone I've ever worked with in my life had to debug. And I actually have helped some of them debug, okay?
Right.
So, yeah. That's just the way it is. I mean, you know, we're all human and we're not, you know, okay. Okay, so here we go. Hit start button. First one comes on. Timer's timing. Second one's on. And the third one's on. And now let's trip our overloads. So number one, tripping. There it went. Okay. Start all over again. I can actually go ahead and trip it. I don't have to really wait for one of them to time out.
Right.
Yeah. Even though that wouldn't happen in real life, it couldn't have tripped if it hadn't cut on yet. But you see that your circuit's fine.
Right.
We checked your logic 100%. So that was very good. Let me tell you, man, you come a long way. You know that.
I know.
You come a long way since that Saturday we were trying to get your software installed, hadn't it?
Right.
and you were struggling with that internet at home. Did they ever fix your internet?
What we're doing, and hopefully it'll be put in this week, we're going to business internet.
Yeah, that's expensive.
Well, not really. It's only about $30 more what I'm paying now.
Huh.
Is it still going to be satellite?
Yeah, because I still can't get nobody else out there, unfortunately. Star said they can't guarantee me but 10 and maybe a 1 upload. 10 definitely download, but they can't promise me 1.
Star Vision?
Yeah.
Wonder why.
Because I ain't got fiber optic out there.
Oh, okay. I see. I understand.
My problem.
Now, see, if they can get fiber optic out there, then they can guarantee me the 1.
Well, yeah, they can guarantee you a whole lot more than that.
Right. But now with me going business with the satellite instead of doing residential, I'll be linked up to what is it called? I'll be overriding a lot of people. I'll be more in demand than most residentials will be. If that makes any sense. You see what I'm saying now?
Yeah. Okay.
So I'm hoping it works out.
Yeah. I hope it does too.
Yeah.
Are they going to guarantee you a certain amount of upload speed?
Well, supposedly business is supposed to be able to get he told me to, and I can't remember now. The upload speed's supposed to get to 3. Okay. So we're gonna see we're gonna see how it goes.
That's what I've got. I mean, I've got around 3 upload speed.
Right now mine's 0.38.
Right. That's pretty that's you're just barely getting by with that, yeah.
Yeah, I can't even get that on mine. I got 0.01.
I don't know what's happened, but like in the past month or so, it's gotten worse than it usually does. I think it might be because everybody else on the internet.
Well, that's what the guy told me, even the satellite. He says what it is bogging everything down because the schooling is online, businesses are online. He said, but if you go into a business one, your satellite's going to be automatically changed. You'll be going into a more demanding satellite.
Yeah.
Whenever I'm sitting there trying to do homework or something, it seems like every other window I try to open, it's like if I stay on the same window, usually it doesn't affect me too bad. If I try changing windows or opening something new, usually that's when it kicks me off and I have to disconnect, reconnect.
Yeah.
Weird.
Yep. Roger, I'm gonna be checking to see if you can get Star Vision where you're at. I got Star Vision fiber, and it's a whole lot better. And I run a hardwired Ethernet cable from my router in the living room back to the back of the house, and that has really helped things 100%.
I'll be honest, if I knew we could get Star hardwired Ethernet or what did you say it was, fiber optic?
Yeah, fiber optics coming into the house. And then I'm using a hardwired Ethernet from a router back to this room I'm in.
All I'm saying is if I could pay for that, I sure enough would, but I don't think they'd offer it here.
Okay. Now,
Durwood, you mark me off with the Logix and the emulator. I mean,
yes, sir.
Yeah.
I got you on both of them.
Okay.
Mr. Durwood.
Benjamin.
Yeah, I sent you a new version of mine for the Real PLC, and I have my emulator ready.
Okay. Go ahead and do your emulate.
All right. Okay.
Darren and Justin, how are y'all doing?
All right.
Okay, good. Got the first one's on. Second one's on. Good. All right, trigger one of your overloads now. Great. Do you see how it cut everything off?
Yes, sir.
Does it make sense what you're seeing?
Yes.
Okay, good. All right, now, so that's perfect. That's enough on that one. We'll go ahead and look at your real one now. Let me check you off on that one. Let's see, Benjamin on emulator. Yeah, you guys are doing an amazing job. I mean, several of you don't really have the industrial background. Benjamin, you don't really have the industrial background, do you?
None whatsoever.
Well, you're gonna be a good right hand man for Francisco. Yeah, I got to get over there and see that new system, man. I haven't been over there since they got all that new stuff put in. I'm wanting to go get some pictures and make a little video and use that to show at school, you know.
Yeah, it's basically the same stuff we're doing here.
Yeah, it is. It exactly is. Yes, sir. Yep, absolutely. So I think I've already saved your
Yeah, but I sent you a new version. I had to make some changes.
Oh, what? What? Make some changes. Okay. Yeah, you're gonna be a really good, strong right arm man for Francisco there, for Bill. I got to get over there and see that. Does that system run pretty good?
Yeah.
That's what they say, man. I'd love to see it. Okay. I remember when Bill Turlington come out to the school looking for somebody. He said, "You got anybody this young and really good at this stuff that can learn and grow up in our company?" And I said, I got the man for you, Francisco Martinez. And it worked out, and I'm very glad. Thank God for that. Let's see. Let's go to Benjamin. It's not just everybody that can handle the environment out there. Like when it's hot, and when it's cold out there, isn't it?
Yes, sir.
That's the part that there's not everybody can handle it, and that plus that knows what to do. So if you know what to do, some people, again, they've got to have climate control. Where you're at, you've got to be a real flexible person. But it's worth it in the long run. I've worked in some real hot areas in my time, and it's tough, but
it's hot right now, especially.
Right. This is your emulator here.
I think I sent you the wrong one.
Right. Yeah, that's the emulator. Yeah.
All right, let me send it again.
Okay. Okay. Who else can we check? How about Darren and Justin? Systems, do y'all have anything?
Hey, Durwood.
Yeah.
Quick question. I was talking to Billy the other day over here at Hoxlat.
Yes, sir.
And the new machines that they're putting in the new building, they're going to be ran on the Siemens. Is there a real big difference? He said he likes that better than the Studio 5000, the Allen Bradley.
I haven't looked at it, to tell you the truth. I haven't seen Siemens in a lot of years. We had some Siemens where I worked at. If you can find out, just find out what family of PLCs it is and what software package, and maybe he can get you a copy of it, or maybe
Oh yeah, we probably. I mean, I don't think we'll be working on them because Billy handles that stuff. But I was just wondering if it's a little easy. He says it is. I was just trying to see what your opinion was.
I haven't looked at it. I don't know what Siemens is doing now. The
Right.
last time I looked at a Siemens PLC was in 2009.
Right.
And it was older stuff. It was not the newer stuff. I don't really know what they've got going on now. Evidently, they must have bought their equipment from overseas then. Did they buy it from Europe? Did it come from Germany or somewhere?
I could not tell you that answer.
Right.
All that stuff come from Japan.
Is that what it is, Jamie?
Yeah.
Okay. A lot of time, if you buy something from Europe, it'll have Siemens on it, unless the company, like it. If you're an American company and you buy from Europe or buy from the Far East,
okay,
you're gonna get probably a Siemens or Mitsubishi PLC,
Okay.
But unless you specify, but you can specify and tell them, now listen, I don't want that kind of PLC. I want an Allen Bradley. And then those foreign companies will put an American PLC on there, but you got to tell them.
Oh, okay.
I told you wrong. The robots come from Japan, and the blow mold injection machines come from Germany.
Germany, there you go. Germany is going to be Siemens world. That's because that is Siemens country over there, But let me just tell you this: as long as they're using ladder logic programming, you'll be able to read it.
Right.
Now, if they go into using function block or doing structured text as a different style of programming, it's going to take some learning for you to learn it.
Right.
But if it's in ladder, ask Billy, are they using ladder logic style?
All right.
And most people are. Now, at Schindler, there's an engineer out at Schindler he's using function block or structured text. And he's not using ladder logic style at Schindler on their escalators, which he told me that he had to use it because of the way he wanted to do the programming. But under my breath, I kept thinking, I don't know of anything you cannot do with ladder logic. And I can't imagine there being something you couldn't do with ladder logic, to tell you the truth. But I'm not the engineer there, so I can't really say. But
right.
All I can tell you is ladder logic is a language of choice from maintenance personnel to troubleshoot. It is the best thing to use. It is the easiest thing to read, and it's the fastest thing to troubleshoot. So what you're learning is the most popular language that this user will be ladder format, you know.
Right.
Yeah.
I sent you the email again, Mr. Durwood.
Okay. All right. But again, there's if any of you whoever bought the textbook for this class,
I do.
The textbook has got the other languages in there. You can go in there further on. You can read on function block programming that looks different than this, and structured text, and you can read up on those further in the book. We won't really get into all of that. There's not going to be time this semester to get into it. It would be for a level 2 class.
Okay.
And I personally don't like them languages because they're very cumbersome to read. They're not as clear as what we're doing now, and not as popular. Not as popular either. Let's see.
Yeah, I was just wondering.
Yeah, but you know, you find out. Ask him what style of language are they using? Are they using ladder format? And this is Benjamin. Okay, right there you go.
Yeah.
Okay, I've actually got to cut that file. I've got to actually close the file to be able to write on top of it. So let's go back to here, and let's do a under file. We have to hit close. We got to take our hands completely off of that file to be able to write on top of it. Okay, now let's see. Go back to email, and here, and save as. There it went. Okay, good. And here, and open, and sequence control. I tell you what you can do, Eric.
Go ahead.
Get Billy to open up a program one day and let you kind of see one of the screens. And take a picture of it and see, does it look like ladder Logix? Just see what does it look like.
Well, they're still trying to get the stuff put in there. And
okay, I see here.
Yeah. It's for the new building that they're building.
I got you. Yeah. But I would like to see it myself. I would love to see I would like to see what they're doing as far as their style of programming and all. I would like to see it. And I could actually, if there was enough Siemens in Sampson County, then I would actually order some Siemens PLCs and I could actually teach it. But I have to get familiar with their new software. But it wouldn't be that big of a deal switching over. You know, your addressing styles I know would be different, but logic is logic. And I don't care what company's using it. The ladder logic is the darn same. I don't care what brand PLC you're using, it's the same.
Okay.
You know what I mean? And, or, not, or, combination, NAND, NOR, all that stuff is the same. I don't care where you go in the world. Everybody's using the same logic, okay? There's not so many ways you can do something. You know what I mean? So
that's true.
But now, what is different is programming styles. We're using ladder programming style here. It looks like a ladder. Now, if they switch over to another style, it's going to look different, but you can still learn it. There's nothing out there you can't learn.
Absolutely. Oh yeah, I agree with that.
Listen, you know, if you find something that's unusual, I could probably help you learn it. As long as you give me time to figure out what it is, and I can figure it out, and then I can help you learn how to read it, whatever it is. I haven't seen nothing yet in my life I haven't been able to figure out with logic or programming so far. So far.
All right.
Because it's, again, there's different styles and ways of doing it, and you can learn any of it. You can learn any of it. So here I've done a lost track of what I did. I had a brain freeze right here. Is this the new one? Have I already got the new one on here?
It's supposed to be on Brandon's, I think.
I'm supposed to be on Benjamin.
Yeah.
Benjamin on that one. Yeah, I had opened it, and we're actually downloading. We've downloaded it. When I get to talking, I'll here we go. Hit start. Let's go smaller. Okay, back up one more. No, can't do that. There we go. Right there. Hit with start. That's the first one. Second one, doing good. Good. You see the lights, Benjamin, in the webcam?
Yes, sir.
And you hear the clicks?
Yes, sir.
All right, so let's trip the overloads and see what's happening here. Number one. Good. Trip the next one. There it went. Trip the next one. Perfect. Does it make sense what you're seeing?
Yes, sir. Pretty cool.
Okay. Like the overloads, do you understand how the overloads are actually kind of backtracking and cutting everything off?
Yeah, by you flipping the switch.
Yeah. So when you flip one of these, then it's giving you a contact closure here on input 8. It's causing output 7 to come on, and then output 7 is cutting off all these examine offs are cutting off.
Right.
Just shutting everything off that precedes it. There it went. If I get the right one. Okay, good. Great. Let me sign you off on that. So that's Benjamin on the real one. Very good. Okay. Mason, why don't we backtrack to Mason, because he's got one that's you still with us, ain't you, Mason?
Yes, sir.
Okay, let's backtrack on one of yours there.
All right.
I want to help you. How's your back doing now? I know you had back surgery a while back.
It's doing pretty good. No problems.
Good. Yeah, I'm looking at getting surgery in November on mine. Lower lumbar fusion. Yeah, I got some major stuff going on with mine.
Yeah, it wasn't fun for me. That's all I can say about that.
Yeah, mine. I can't let it sit the way it is. I got arthritis.
Mm-hmm.
On the inside of my spinal canal, and it's pinching in on my spinal nerve, and I got 3 vertebrae that have actually getting dislocated in there. I got some serious stuff going on. So, okay. So how do I download this program? Yeah.
Let me look at it. Go to Who Active or Communications.
There you go.
Who Active. Virtual chassis. Right.
Well, that's going to be for your emulator. That driver's for your emulator, but for the real thing over here is what?
I forgot. Just to be honest. The Ethernet.
Ethernet. Yeah, it's the type of cable that we're dealing with.
And then click on that. Download.
Right. Yeah. Do you know what kind of PLCs you have at your plant, Mason?
We have some Allen Bradleys, but most of them are Siemens.
Okay. So your equipment come from Europe then, didn't it?
Yeah, our presses come from Germany, and our bottling line come from Italy.
Okay.
And now we're supposed to be getting a cannon line coming from Canada. So.
Okay. Well, if you whoever looks at your logic in there, have you ever been able to see any of the programming screens like this?
I haven't personally. No. I don't know if anyone else has. We have for our guy machines, which is our bottling line, we have internet running to it so they can access it from Italy if they need to.
Yeah.
So they look into it a lot if we have problems, but
Yep. Okay, now if you look on this, you see my hand moving in the webcam.
Yes, sir.
Now watch this switch over here. I'm gonna go to hand. You see it go to hand?
Yes, sir.
You see it light up the green on the screen?
Mm-hmm.
Now let's go over to the right to auto. You see that?
Yes, sir.
Okay, now we're gonna go back to hand and I'm gonna hit start. I did that and that's perfect. So the starter came on. I hit stop. Now let's go to auto. And now let's get our float switch. You see the float switch in my hand?
Yes, sir.
We're gonna go up. There it went, up and then come down. I bet you got a bunch of floats out there where you got in the tanks where your wine is, don't you?
We do. We have a lot of float switches.
Right. Yeah. So it goes up, pump's coming on, goes down, pump goes off. Now that is if you're trying to pump, if you're pumping liquid out. So
Yes, sir.
when the float goes up, it's going to cut a pump on, and that a normally open float would be used to get rid of liquid. A normally closed would be used to bring more liquid into a tank.
Yeah.
So picture this float here hanging down being normally closed, and the pump running with no liquid in the tank. And then like in your case it's wine. So let's say if you're calling for wine to come into a tank and the float is down, then the pump would be running on a normally closed float until the tank gets full of wine, and then the float goes up and shuts the pump off. Then the normally closed float would then open up. You see what I'm saying?
Yes, sir.
So it would be the opposite. It would be a normally closed float if you're going to turn a pump on that brings liquid to the tank, it's going to have to be a normally closed.
Yes, sir.
Yeah. So anyway, that's the difference there. Here we're talking a sump pump where water's coming to you and you want to get rid of it.
Mm-hmm.
It's being sent to you, and you're not even calling for it, but it's being sent to you by some other place in the plant.
Yes, sir.
It's wastewater,
Yeah.
Y'all, I'm sure you got wastewater in your process, don't you?
We do.
And when it goes, do you clean it yourself? Do you process and clean your own wastewater?
We send it to the town of Rose Hill.
Okay, so in other words, they can handle your wastewater.
Yes, sir.
Right.
Yeah, it's not super big or nothing, but we do have it.
It's natural coming off of grapes.
Yeah.
Right.
But like in grape season in September, we have a collection tank. When we press juice, we get grapes and we press the juice out of them.
Right.
And it'll dump in a collection tank, and we have a lead and lag pump that pumps into tanks inside the house so they can ferment.
Okay.
So we got a lot of float switches for that. Yep.
Okay. So does this logic make sense? What you wrote here?
Yes, sir.
Good. I'm gonna put you down here. You got this one? Great. Let's see. So this is for the real sump pump. Great. Okay. All right. Let's see. Can I help you on anything else right now?
No. I mean, you can look at let me pull it up real quick. I did the timer on.
Okay, good, good.
I've done that one, and that's about all I've done so far. So.
Hey, Durwood.
Yeah.
Before I leave, is there anything we need to know before I leave?
No, I've got to get you another lab prepared. I don't have another one on the thing, but you can look ahead. What I would do for now.
I know I got to do the Chapter 3 worksheet. I do know that.
That's what I was going to say. You guys, please keep an eye on your chapters, because we've only got to July the 8th, and I'm going to be adding a few more chapters in. So on the in-between times, try hard as you can to put some time into it. The hours that we're basically, you got about 5 hours a week now that you're not getting, that you would be getting at school, and it's gonna take some time on your own to actually get your worksheets done to read the chapters. And I'm sorry that you're having to do it completely on your own, but actually you're not really completely on your own on it, because if you get something that's not making sense in a chapter, you can contact me at any time, day or night, and I'll work out some time with you to discuss anything in the book that's not making sense. So keep that in mind and take advantage of it, because I'll help you on the weekend or whatever. I'll do my best. Now, if I'm at a restaurant somewhere, then I'll tell you that, and I'll say, well, when I get home, I can go online and help you. So, within reason, I can help you on weekends, working between other stuff that may be going on here. So I'll do it. I'll do it if you let me know. I will do it. So y'all keep that in mind. All right. So this is okay. You want to go ahead and toggle your start button?
Yep.
And then toggle. There you go. Great. Yeah. Do you remember seeing some of this stuff on the automation system?
Oh yeah.
Right. So now you're getting to write it now. So that's good. That's perfect. Let me put you down for that one.
All right.
Very good. I would like to see if you could take if you could get a picture of some of your logic, just one snapshot on the phone and send it to me. I wouldn't mind seeing some of it. Same thing with Eric on your Siemens. I would like to see it, and we may be able to discuss their addressing style, if we have time.
Right.
Because their addressing style is going to definitely be different. It ain't going to be hard, but I know it'll be different.
Right.
So every company's got a different way of doing their addresses, and it's just once you learn it, then it's simple, So.
Right.
I worked with Siemens for about 20 years, but it was stuff from Italy, and the programming style was not even ladder logic. It was a sequential. It was kind of like structured text was kind of. It was not hard to read, but it was not ladder, But it was not that hard to read. It couldn't come from Italy. It was custom software from Italy, with a German Siemens PLC. I can help you with any of it if you can just let me see some of what you have.
Yes, sir.
I'll try to help you with any of it. I don't care what it is. I'll jump right on it, and I'll try to help you figure it out. And I would actually like to see it.
Yes,
I want to know what's going on in the plants, because the more I know about what people have, that can help me to modify what I'm covering. You know what I mean?
True.
It may be that I need to start covering some Siemens with y'all.
Right.
If there's enough of it, I just know that at Smithfield Packing and Butterball, Allen Bradley is dominant. They are the most dominant company of controllers they've got. But again, if there's enough Siemens around, now I'll start including that, and I'll probably order some and get into the software.
Most of ours are Siemens. The only thing that's really Allen and Bradley is our refrigeration systems, but I mean, there ain't a lot of them.
Right, and so that's because you're buying from Germany and Italy.
Mm-hmm.
Well, so if you if you can get whoever's in charge of your, is it your dad? Does your dad have access to the programming?
I'm sure he could get it. I don't know if he's got it or not. I would have to ask him, but
Right.
He wanted me to do this class. He was very excited about it.
Well, good. Whoever, while we're in this class, if you can like this week, maybe tomorrow, if you can get some snapshots, at least one snapshot of some logic on the screen, and send it to me, I want to see it. I want to see what it looks like, if you don't mind, if they'll let you do that.
Yes, sir. I'll see what I can do.
Yeah, do that. The same thing, Eric, if you'll ask Billy to let you get a picture of one of their logic screens, and we can talk about it, you know.
All right.
You know, and I'll dig in and I'll try to help you figure out what's going on with it. So, you know. Yeah.
Hey, Durwood, I got a question for you.
Okay.
It's not necessarily related to this, but to get your electrical certificate and stuff, what classes do you need?
ELC 111, 113, 117, and then this one, 128.
Okay. Well, what was 113? Is that residential wiring?
Residential, yeah.
Okay, so I should have all of them then.
Right. So what you need to do to get it is you need to contact the registrar, which would be Billy Joe. I forget her last name.
Pittman?
Huh?
Isn't it Pittman?
It is. That sounds right.
Yeah.
You need to you can call her and tell her, or email her and tell her that you want to put your name in the certificate, the electrical certificate program.
Okay.
It's just like getting into the industrial systems program. It's got a catalog number of its own.
All right.
And once
I
just
want to make sure.
Yeah. When you tell her that, let me know that you've told her, and then I'll go ahead and I can do a verification form like really soon.
Yes, sir.
That'll verify that you can get it. And then as soon as the grades are turned in, and however long it takes them to process it, they can get you a certificate. You know, and I'm sure they can get it to you by the middle of July. You know.
Yes, sir.
Yeah. So just do that, and let me know whenever you talk to her, and then I'll send her a verification form. I'll check your eval and look at make sure that you got the other classes, which I know you do. And
Yes,
then I'll send her my verification, and then once the last grades are turned in, then they'll process and they'll print you a certificate. And they can mail it to you. They can mail it to you if you want to mail it.
Yes, sir.
Okay, that sounds good.
All right.
That goes for all of you. For all of you, once you get ELC 111, 113, 117, that's motor controls, and then this one, 128, you can get electrical certificate. And there's also an electrical degree starting up in August. There's other classes starting up that you can get a 2-year degree in electrical systems technology. So everything you're taking now goes into that program plus more, you know. There's other stuff involved, like at National Electric Code classes. There's classes on solar fields, like these solar panel fields. There's 2 classes on solar panel circuits, and that's the main thing that we're not doing now. Is dedicated classes on electric code. There's 2 of those, and then there's 2 classes on solar panel circuits. And then with that combined with everything you're getting now, if you put all that together with your electives and with your general ed, it gives you an electrical systems degree. So,
Durwood.
Yeah.
What'd you say? 111, 113, 117, and 128.
Yeah.
Okay. Ain't there another one that's the alternative?
Well, there's another one higher than all. The highest one is ELC 215, and it's in the degree required for the degree. It's not required for the certificate, but you need to get it because it's using what you're doing now, but it's doing it on a scale to where you're doing a lot of troubleshooting on an assembly line we have at school.
Right.
It's an automation system. It's already wired and programmed, and
that's the one in the spring, right?
Yeah, it is.
Yeah. Okay.
Yeah, and I've asked for it to be at night too.
Right. Okay.
Yeah, it should be a 6 o'clock to 8:30 class 2 nights a week.
All right.
Yeah.
Well, Durwood, I'm gonna sign off and say goodnight.
That sounds good. You have a nice evening and a safe trip home.
I will. All right, Jamie. I'll see you tomorrow.
Okay.
All right, dude.
Have a blessed evening.
You too.
Now, Jamie,
I think I'm gonna
don't we
scuddle
need to
out
see
here
more?
too.
Do what?
I think I'm gonna get out of here too. Y'all have a good night.
You too, and I'll have another lab posted up there before Thursday.
All right.
Okay. And Jamie, don't we need to check one of yours?
Yeah, I don't know that we've checked any of mine, to be honest with you.
I don't think we have, man. I'm sorry about that.
No, that's fine. I'm just sitting here watching what's going on.
Yep.
Yeah, that's me to host class. Hey, Durwood.
Yes, sir.
So we're just gonna have like one more new lab for Thursday night.
There'll be another lab. Yep. There'll be a new lab. Yeah.
All right. Any new worksheets?
Well, if I get time to put another one on there, I don't know that I will between now and then. It'll probably be the weekend before I can add another chapter.
That's fine.
But I can actually I can probably go ahead and put 2 labs on there easily.
I was asking just so I know about what I had to do.
Yeah, what I'll try to do is between now and then is put 2 labs on there.
Gotcha. I still got to catch up on the other class. I've probably got 2 or 3 things still to do in the other class.
Okay. But I'll try to put at least 1 lab, and I think I can do 2 labs on there pretty easy. You know.
All righty. Thank you.
I'm getting in the swing with Moodle, getting everything converted, so it don't take me long now to get it in there.
Yeah. All right, and we'll get off here. Y'all have a good night.
You too. Have a blessed evening, man. You going to the beach tomorrow?
No, it's Thursday. We're going Thursday morning, and we'll be over there by the evening. And they said I'd have it be there by 6 to do my class and mess in the room.
Okay. Good.
All right. See y'all.
You have a good one.
You too.
Now, so Jamie, we got to check your latch. We're backing up to your latch circuit.
Mm-hmm.
So, let's see. I think I need to see your emulator latch. Yeah.
All right. I'm gonna have to pull it up there with.
Mm-hmm.
All right. Let's see. You got to give me a minute.
Okay. I'm going to step away from the camera for a minute.
All right, that's fine. Documents. That way. All right. RTO, Emulator, latch on latch.
Okay.
All right, it's still loading.
Okay. How do you feel about what's going on now with all the program and all? You like it pretty good?
Yeah, it's a lot to take in like this.
Yeah, it is. Yeah.
And I've been spending quite a bit of time going back watching the videos on stuff I really didn't understand. But I'm gonna do. I just pulled it up. Let's see. I need to do a screen share, so let me do that.
And pretty soon we're going to cover some differences between the 5000 and the 500 software.
Right.
In chapter 4 we've got to cover some of it. I'm just going to show you the differences in the addresses.
Right.
And instead of using tags like we do now, you don't use tags in the 500. You use data files. And so there's only two major differences between that software and what we're doing now. And once you see it, it'll help you understand what you're going to be dealing with. A lot of your older stuff at Hogslet.
Right.
And even at Smithfield Packing, they got a lot of 500 controllers that are still there. But they got a lot of old and they have a lot of old and a lot of new. Excuse me. The 500 stuff's going to be still running for a lot of years because it just holds up. It just runs. You know what I mean? It can run for many, many years. You know. But it's the newer equipment. When people build new equipment now, they're not going to put the 500 on there.
Right.
Because eventually they'll
wear out. They'll wear out, and they'll have to upgrade.
They'll have to upgrade. Yeah. Yeah. It's just like it was before the 500. It was PLC 5. Well, I came in on the PLC 5. I actually came in on the PLC 2 generation.
Right.
My stuff goes back to 1989, working with PLC 2, and then it went from 2 to 5 to 500 down to 5000. So.
Okay. Yeah, I was going to tell you when I had a chance to talk to you, which I didn't want to do it during class or whatever, but we sell a lot of stuff, a lot of electrical equipment.
Yeah.
We not only do we sell to the hog farms and poultry farms, but we sell a lot of stuff to nurseries and greenhouses and. So we got service technicians, and that's what they do. They go out and do repair work on the equipment. Replace motors, fans, augers, feed feed lines, all that kind of stuff. Which, believe it or not, is an upgrade from a maintenance man.
Money wise.
Yeah, money wise, and just the actual job, the conditions of the job are actually better than what we have to do a lot of times. So, and you learn a lot of stuff. They do a lot of the stuff we got, and Will and them guys that run our R&D department are constantly making new stuff. We have you'd be amazed if you went into a hog house how much of it is automated and runs off of stuff like this.
Yeah.
So they needed somebody, and they wanted to interview me for it. I interviewed for it, and they gave me the job. So
that's good.
Ronnie was okay with it. So I'm still going to continue getting the, I'm working toward getting an electrical certificate.
Yep.
Which I still work for Hogslet. It's just I'm going to be assigned to a different department in 2 more weeks. So, but they know what I'm doing with the school, and not only do they want me to finish, before they hired me, they spoke with the other repairmen, and they all agreed to cover my time to make sure I could make these classes come. They want me to. They still want me.
That's a blessing there for sure.
Absolutely. So
that's good.
And Terry retires in 2-3 more years. I may just transfer back and take over at his spot or something. I don't know.
Who?
Terry Williams. He's more or less the main maintenance man out at Clinton.
Okay.
there's a, I don't know, we just got so much equipment, it's a lot to learn. They're actually, I'm gonna be working with Mark Rose. I don't know if you know Mark or not, but
No.
I'm gonna be going out with him for anywhere from 4 to 6 months being trained.
Okay.
So, and it's actually I'm gonna probably be doing more electrical work than I am now. So
that's good.
Yeah. So all this stuff.
You'll do great. You'll do great. You really will. You'll do really great.
Well, Ronnie, Ronnie's the one that come and asked me about it, and we talked about it. And he, of course, he didn't want me to take it. But at the same time, the way he worded it before I even interviewed for it, he said, "I'm just going to tell you, you're going to learn a lot, and it benefits you greatly to take the job if they offer it to you." He said, I would feel like," he said he'd feel like he was holding me back if they offered it to me and I didn't take it. So
yeah, that's good. So he's not being selfish, yeah.
No, and they gave me him and Chuck gave me the opportunity. Chuck's the one that actually recommended me for it. And we're all in agreement that, for whatever reason, if I decide it ain't for me or they decide I don't work out with them, I just go back to doing my same job now as a maintenance man. So
okay, that's good. That's real good. That's nice.
All right, you see what I got up here?
Yeah, oh yeah. Go ahead and toggle it on. Okay, toggle off. Good. So you see it stays latched.
Yep.
Okay, now hit PB2.
Okay.
Perfect. That's got it. Yeah. Let me put you down for that. Does it make sense what you're seeing?
It does.
Okay, good. Let's see.
I tell you though, I'm looking forward to the fall class being able to to get in hands on.
Yes, sir. Yep. You'll ace it's introduction to electricity from 12 to 2 just on Tuesday in person. On Thursday it's going to be a Zoom session. So
the class I'm gonna be the class I'm signing up for is the residential. They're gonna let me take it.
Okay. So that'll be from 6 to 9 o'clock 2 nights a week on campus. And then the lectures are going to be, I've got to pre-record them and put them in Moodle or on YouTube through Moodle because they trimmed the time back and they said it had to be a hybrid class.
Right.
They don't want me doing any lecture on campus. They don't want lectures going on in the classroom now.
Right.
They want lecture going on remotely.
Okay.
So that people are not going to be elbow to elbow in the room,
No, that's understandable.
They don't want that. So the book portion is going to be through sessions like this, but I'm going to have to pre-record them because the hour that we're missing every night from 9 o'clock to 10, you would normally be there to 10 o'clock.
Right.
But that last hour they trimmed off. Yes, I've got to make it up. We've got to cover the book, but it's going to have to be done through. I have to do recordings. I have to do 2 recordings a week and put a link in Moodle.
Right. And
everybody's going to have to watch them recordings to learn that book. If you don't, some people will be lost, So
I'm gonna be honest with you, though. That's I think that platform is probably gonna work out well. Yeah. Simply because as long as people do what they're supposed to do at home, because then they've got the opportunity to watch it, absorb it, but then they turn right around when they go to class. They can ask you about it if they don't.
That's right. That's right.
And we're going to have more time to actually be out there doing the hands-on.
That's right. Physical. Right.
I think that's probably going to work out pretty good.
Yeah, I think it will. Yeah. It's going to take more planning from me. I've got to look ahead and do the recordings up front. But it's okay. It's just a swing. It's another little swing I've got to get into. It'll be fine,
Oh yeah.
Yeah. Okay, so that was good there. And did you have another one? I think you sent me some other stuff, didn't you?
Yeah, I think I'm caught up on everything.
Let's see what you got here.
I'm gonna hit the stop share.
Okay. Now I don't see you down for the off delay timer and the RTO. I don't remember seeing them. I didn't write down that you did have them. So let's check and see.
Yeah.
You want me to check them, or is it getting too late for you?
No. You check whatever you need to check and make sure I've got everything that you need me to have.
All right, let's see. So you have a TO. Have you got the emulate that you can show me how to emulate runs on TOF and RTO?
Yeah, I'll have to pull it back up.
Right. If you'll do that, and then I'll run the real ones that you sent. Yeah, I'd love to see some of your Siemens programming, because I just want to know what's going on in plants, you know.
Right. Let's see. I need to close that. All right. So let me go back to here and there. All right. And which one did you want to see, Durwood?
The TOF and then the RTO on the emulate.
All right.
Yeah, that's it. Yeah. I bet you in those greenhouses and all, and the hog house, I bet they got a lot of specialty PLCs. They might not be Allen Bradley, but they'll still be PLC type controls, you know.
They do. They have a lot of that stuff that runs, because everything from the air blowing in there to the humidity level, the lights, the gates that turn at certain times to let movement happen between the hogs and the chickens, and all of that stuff is run off of this.
Yep.
So that's why Ronnie was like, if I don't let you take it, he felt like he'd be doing me a disservice. So
right, yeah.
And we talked about it, and I decided, you know what, I'm gonna go ahead and do it.
Yep, that's good. I'd be curious to know what their logic looks like, what style. Are they using ladder, or most people are going to use ladder logic like what we're doing, because it's maintenance friendly. It's any maintenance guy can learn it.
That's kind of the weird thing about hog slat. I'm glad they're letting us take the class, and me and Eric both, we talk about it a lot, but they only have like Travis and Billy Farthing, and they've actually got a couple people that work for outside companies that specialize in this stuff.
Yep.
They pretty much don't let us do any of this. If something burns up, we can replace it. They would let us pull out a PLC and install and wire up a new one, but they wouldn't let us power it up. They would have to be there to do that. So.
Yeah.
But you never know what's happening down the road. You know what I mean?
Well, the job you're getting into now, doing field service,
I'm actually going to use more of this.
You're going to use more of it.
Absolutely.
You will.
All right, I'm on remote run, so.
I don't see you're going to have to update your screen. I still see your files.
All right, let's see.
Have to cut screen share off and cut it back on.
Okay.
Yeah, I'm still seeing a list of your files. It's kind of froze.
Okay.
When you go to do screen share, you'll see some different blocks up there. You have to pick the right block to where you want me to see.
How about now?
Yeah,
That the right one?
But really, I'm only seeing, you need to hit your dock button. I'm seeing just part of your logic. Yeah, you need to slide your logic back over because it looks like it's behind the organizer.
Yeah, I don't know what in the crap I've done. Come on back up.
Mhm.
There we
Now, you still got part of it here. You need to go up to the top where it says controller organizer and right click and hit dock. Well, it already says docked. You have to resize your windows so that you can see the whole thing.
Yeah, I don't know what in the crap I'm doing.
You got to get your ladder logic over further because you're missing part of your rung there. I think you're going to have to do it maybe at the bottom. Yeah, there you go. That's it. That's exactly what happened.
I hit that and moved it somehow or another.
Yep.
All right, so let's see. Toggle this. All right, then I need to do the stop button, right?
Yeah, you'll toggle on, toggle off there.
Toggle bit.
Now, once you highlight the bit, you can actually hit Control T on, Control T off.
Right.
So for an off delay, your service light comes on instantly. You wouldn't do a service light for off. It would be a fan, a cool down fan for an oven.
Right.
So the fan comes on with no delay, but then when you hit the stop button, it keeps the fan on for a while, and it's going to count, and it's going to give you X amount of time after you hit stop. So if you toggle your stop button now.
All right.
Now you see it counting now?
Yes, sir.
Now, so it's a countdown to how long you're going to keep it on after you cut something else off.
Right.
So if you hit the stop button and it cuts the oven off, then it's going to let the fan run longer than the oven, you know.
Right.
To cool everything down, to get the heat out of the combustion chamber.
Correct.
So that's it. Okay, let me check that off that you got let's see. Okay, now the RTO.
What's the easiest way from right here for me to get back to it?
Go up to the open icon, just the one over to the left. No, it's the second icon. Yeah.
Right there.
Yep. Mm-hmm. You just hit that one. Well, wait a minute. You got to go offline. You got to go under remote run. You got to go offline.
All right.
Yeah, I forgot to tell you that. Okay, now well.
I ain't gone offline yet.
Okay, all right.
All right. So I'm offline. Now go
under open, and when you open another one, it's just going to close the one that you got now.
All right, so the RTO.
That's it. Yep, that's it.
All right.
Good. Now you have to download it now. Yep. Yeah, I knew you were going to be. I know you were going to be a winner on this stuff, man.
Yeah, I would feel a lot better if we were, if we were doing hands-on. But I'm gonna tell you, it's pretty amazing.
Very amazing
what we're able to do with this.
Very amazing. It's a god. It's nothing short. It's a godsend, man. It's what it is. Absolutely. This thing is way beyond. It's way beyond what I thought we were going to be able to do. I knew they've had emulators out a long time.
Yeah.
I've never used them, and then I didn't know that we were going to be able to do a classroom conference like we're doing and do screen sharing. And the quality of it's what's really surprised me. This made it to where it's worth it for y'all to do this,
Oh yeah.
This is not a bunch of Moodle stuff just to say you've done something, So, some classes are nothing but paperwork and reading, and there's no really doing, of the material. But here, you're pretty busy. Now, hit your stop now. You see it keep that time.
Yeah.
So the RTO is retentive in that it'll keep it if you hit stop or if you cycle the power, it's going to still hold it. You know. Did you see me cycle the power one night and how it kept the time?
Yeah, I sure did.
It'll do it. It'll do it. It will. Now, your older PLCs have batteries in them, like lithium battery, to hold that program to retain your RTO.
Right.
But the newer ones have got flash memory built into them, and there's no battery, and they'll hold it indefinitely. You know, with no battery. So you can go ahead and let it finish now. You can toggle back on and let it finish, and then do a reset. Yep. And you got to toggle your stop button back on. Yeah, I remember that weekend you had so much problem with your computer that now toggle your start button off. Yeah. Good. So it finished and the service light's on, and now you'll go do the maintenance on the machine. You change the bearings, or change the oil, or whatever you're doing. Then you'll hit the reset button to acknowledge that you've done it. That's it, and that cleared the timer.
Yeah.
So it takes a RES to clear a RTO, you know.
Okay.
And that's like on air compressors or anything that has services, a periodic service on it, like doing PMs.
Yeah, we got a lot of them.
A lot of them. Yeah, good. So when you get them, does a light come on the machine to tell you to go do something, or?
Yeah, a lot of them have a light to come on. A lot of the stuff in Newton Grove's older stuff. Yep. So what we've done, we've gone in and put counters on them, just regular counters.
Yeah.
And we actually physically go around once a week and write those numbers down, and we've got a program that generates and says, you know, when you run, 40 hours this machine, you need to lube this or whatever. But over in Clinton, they've got a lot of stuff that Justin Williford,
yeah,
he does a lot of them, and what they do is they'll actually have a light to come on, and when that light comes on, the operator lets them know, and then he comes and does PMs on them. So
that's what you just wrote right there. That's what they're doing in the machines.
Mm-hmm.
Yep. Okay. So that's good there. Now you tell me time-wise when you need to stop. Now I'm willing to check as much of stuff as you got done, but it's going to be totally up to you.
Yeah, let's go. I want to make sure I'm caught up with everything.
Mm-hmm.
So.
Okay. All right. Well, I'm game then. Okay. So let's see what you got on your real ones there. Okay. You can cut your screen share off.
All right.
Okay. And so let's go under here. Yeah, I'm glad it worked out. You were number 21 last semester, but I knew I said 20 is a lot, but I said when Ronnie Gottman comes at me, that 20 don't really. That's not a stopping point.
Yeah. Well, see, I was actually supposed to. They had agreed to let me go and take these classes the year before.
Really?
Yeah.
Uh-huh.
And Ronnie was supposed to get up with you and find out what I needed to do, and then.
Okay. Uh-huh.
Like 3 weeks later, I'm like, Ronnie, have you found out anything? Nope, I got to find out. And then it was like another week later. He's like, man, the class started like 3 weeks ago. So I said, well, we'll catch it on the next go around. One thing leads to another. And
yeah, I saw him at the grist mill.
Yeah.
At the restaurant, I went in there. Me and Barney and Ruben and a bunch of instructors went over there. And there was Ron. He came over there. He says, I've been meaning to get up with you. He said, I got a guy. He said, he's a welder fabricator. He says, but I've lost Aaron Norris, and I want to turn Jamie into Aaron. And I said, kind of in them words, not read literally, but
I know. We was in a bind.
Yeah. And so I said, I looked over at Barney. I said, man, I said, can we get one more in there? I said, well, I got 20. I said, but I said, hey, I'm willing. And he said, yeah, I think we can do that. So that was it,
Yeah, it worked out good. I'm glad it did.
But Ronnie had that look in his eye, and I know what I'm seeing. I can look at him and tell when he is serious as a heart attack. And I said, I knew. He recognizes when it's something worth doing. You know, Ronnie ain't gonna waste time on nothing. He's not gonna, you know. So, and if he says he wants to do something, then it's worth doing. You know.
Oh yeah.
It's worth doing. He don't waste his time on anything. I don't believe.
He don't.
He don't. Okay, so we're looking now at here. Where are we at? We want to see your TOF on the real one.
All right, that's got PLC wrote on it right up there.
Okay. Okay. Yeah, I've got some. I brought so much stuff home, man. I'm in my parents' old room before my dad passed.
I told Ron.
This is the room that they were in, and when he passed away, then my mom don't use this room no more. She's in a different room.
Right.
And so this is my recording studio for my music. I got my audio recording stuff in here for instruments, and then I've done and I got a lot of motor control stuff in here now. So.
Yeah, I told Ronnie because he kind of asked about, how things were going a week or so ago. I said, "Bo, I'm gonna be honest with you." I said, "I think if we go through about one more semester at the college where we can't go to school and Durwood has to bring some more stuff home, he's gonna have problems with his mom." I said, "He's got stuff piled up in there." I said,
"It's piled, man." Yeah, and I've got a 500 controller laying over there on the bed over there, a big one. I'm gonna set it up here on the Cheshire drawer behind on the drawer behind the computer, and cover some 500 stuff with y'all probably next week. Yeah. So I've got a lot of stuff. It's going to take me about four trips on my truck to get everything back to the school. but I'm gonna be honest with you. I don't know that I'll ever take it all back, to tell you the truth. Because you don't never know. You don't never know when I have to revert back to something like this. And I'm not. I don't think I'm going to take everything back that I've got unless I see everything run normal at the school 100% for about a year.
Yeah, I don't blame you.
Seriously, man. I mean, cause
that's a lot. That's a lot to be lugging around.
It's a lot. It's a lot, but I've enjoyed it, and I like doing it, and I've got more ideas of how to do some more stuff here to make it more real. I'm looking at getting some servo drives and servo motors, and getting them to where they run on single phase power going in, and ordering them that way on purpose so I can teach from home and get more advanced on motor controls and servos. So that's something that's more high-tech motor control that's a step up from VFDs. When you got encoders on the motors and you can do real precise positioning,
right? Super
fast and super precise on positioning, way better than you can do on the VFD. So hit start. Okay, you see your logic.
Yep.
Now your output came on, which is a green light in this case. I don't know if you can see. Do you see the camera or not?
Yeah, it's on a smaller screen, though.
Right. So your output came on instantly, and now when I hit stop, now it starts counting. And this is going to be, the green light will be like a cool down fan,
Great.
And so it don't matter what kind of load you turn it on, as long as you see it. As long as does the logic make sense?
Yes, it does.
Okay, good. Yeah. Okay, so let's got you there. Now let's get the RTO on the real one. Yeah, you're getting all the really good building blocks of logic with this class. It's an excellent class.
Oh, absolutely.
And by you having this class, you'll be able to look at programs on machines that are already made. You'll be able to start interpreting a lot of things just by what we're doing now.
Right.
Because what we're doing now is what makes your stuff run. It's just more of it, you know, there are more combinations of it. You know, instead of using just and, you've got and, or, not combination. You've got, it just gets larger combinations of logic, but it's all, most of it's still using the same basic 7 logic functions in some shape or form, you know. Now, we're going to start getting into counters on real soon, counters, and counters are used in programs a lot, you know. Okay, so we're going to hit the start button. You see it running?
Yep.
Hit stop and it remembers. Okay. Okay, your service light came on. And now I'm going to do the maintenance, and I'm going to clear it with input 7. There it went. That's perfect. Very good. Okay, so that's got you on RTO real. And then let's see, did you happen to turn in, you know what, the latch? Have I seen your actual real latch program, the real latch program?
No, we just done the emulator a while ago. You haven't run my latch program.
Right. Let's see. Do I have it? Yep. Right there. I've got to update Moodle on what labs I've seen.
Mm-hmm.
I've got to get that stuff done Friday.
Well, I think I've turned in everything.
Yeah. Mm-hmm.
I think.
Yeah, I'm looking on my hard copy of my spreadsheet here, and that's the what I'm old school enough. I've still got a paper copy of.
Hey, that's a good.
See on the webcam there that the paper copy I got here.
Yeah.
So I still do real paper spreadsheets, because it's just you know I got to have something, man. If a network fizzles out, I've got to have something that I can put my hands on.
Oh yeah.
I couldn't stand being paperless. I just ain't gonna do it.
We're not either. I mean, you know, everything we do is put in on a computer, but Terry still prints out a hard copy of it and puts it in a file.
Right. That's what I would do. That's the way I'm gonna stay too.
Yeah, absolutely.
Yeah. Okay. So we're gonna do our latch, push button on. There it went. And you heard that click, and you see the light come on, right?
Right.
And now we hit unlatch, and there it went. Now, you know that latch is going to stay on. If the power goes off, as soon as it reboots, it's going to turn that starter and that light back on without you hitting anything. Okay, that's good. Now, that would be good on emergency type systems. Maybe greenhouses. It could be a good thing. I would imagine, or maybe even in hog houses for sure.
Yeah.
You know.
Oh yeah, I know they use them.
Yeah.
They have to, because then when the power outages, you know, happen and just you got a 2-minute power outage.
Right.
You may not have somebody there that can walk through the hog house and physically turn on everything. They got a bunch of stuff set up on them latches.
Mm-hmm. Yeah. And I would imagine they got probably somebody monitoring remotely.
Yeah, they do.
Yeah.
They do. They're so automated now, man. It's like Gregory, the boy I helped phone. He's got a bunch of hog houses, and like sometimes, like when he's gone or whatever, it's set up so that if an alert goes off in Clinton at one of his hog houses, you know, it sends an alert directly to your phone and tells you what room it's in and what it is and everything.
Yeah,
and a lot of it he can actually access from his smartphone and activate it from the smartphone.
Ooh. Oh.
It's pretty sophisticated what they got now compared to what they had 10 years ago.
Yep. That's good.
It's like the pump reel. The pump reel at the South Farm, he cuts it off and on, and it's in Clinton, and he lives down here in Clement with me. He cuts that thing off and on with his smartphone. I mean, you know, it keeps sending him information, telling him how long it's been running, how many gallons it's put out per minute, and you know, he sets it up right here.
Yeah, that's amazing.
Mm-hmm.
Okay. So now there's some questions on this latch program. There's questions, and the last time I checked over the weekend, you hadn't done the questions yet, but you may have done them by now.
Yeah, I done.
You may have done them, but I just hadn't done no grading since the weekend.
I've done. What was it? Durwood, I don't remember. I turned in 2 yesterday.
Okay, yeah, and I hadn't checked any of that during the week because I'm just busy trying to get ready for a class. The weekend is when I do the grading, really.
Right.
And tomorrow during the daytime, I may actually get time to do some grading, maybe, but I got to get a couple of labs ready for Thursday for y'all.
You see something that I didn't turn in, it ain't because I didn't want to do it. I've overlooked it.
Yeah. Okay.
But I did 2 of the quizzes yesterday.
Yeah, good. Now, as far as the sequence control tonight, let's see, is that one that you?
Yes, sir. It's ladder diagram.
Ladder diagram. Okay,
Yeah,
I see it right there. Yep. Right. Okay. Getting in the short rows now. Oh yeah. Okay. So let's check your addresses here. 0172. Okay, 1. And then 2. One, 2, 3, and let's see. Check this out. We got output 4, 5, and 6, and then 7 is for the horn. Yeah, that's good. Okay. Now let's go smaller, and let's download. Yeah, you're ready. I knew. You know, you were worried back when you were having trouble getting your computer going in the very beginning.
Yeah.
You had a lot of struggle, man, but it was worth it. And you think it's worth it now?
Yeah.
Yeah, I knew it would be.
I'm a hands-on builder. You know what I mean? I'm not a computer guy, so.
Yeah.
But hey, you've been very helpful in guiding me to the right directions on this stuff.
Yeah, and I will, and I'll help you on beyond the class too. You know, I'm in it for a long haul, man. Okay, I'm gonna hit start.
All right.
Bam, there it went. Your first one with the light starter. 2, 3, perfect. And we're gonna trigger some overloads. How do you like the way we're doing the overloads, interfacing them to the PLC?
Yeah. It's cool.
It is cool. Yeah. And I'm sure you got yours interfaced in too. Well, I mean, I know you've got to, because if it's telling y'all from a cell phone something's down, then you've got a lot of fault detection. This feeding inputs on your PLC, you know.
Yeah.
Very good. Excellent. Okay, that's good. Perfect. Now let's put you down for that one. I just wish everybody was willing to spend the time, you know, that you're spending on it. I got some people that are super behind, man.
Yeah, I know.
Yep.
This ain't something that's easy to catch up on.
No, it ain't, because we're adding to it all the time, man.
Yeah, I know about 2 weeks ago, Gregor had a lot of stuff going on at the farm, and I was trying to help him get, catch his stuff up, and I got behind, and it's hard to catch up.
Yep. Okay, so now the emulator on this one, have you got, you did, I know you did the emulator, didn't you?
Yeah, I sent that to you also.
Right. Can you do a screen share on it and just let me see you run it?
Yep.
And then I think that's gonna do you right there.
Let's see.
Yeah, that'll have you called up on labs.
That diagram emulate.
Yep. I think your screen froze up on me again.
Yeah, it's downloading.
Yeah.
As soon as it pulls up, I'll refresh the screen.
Have you been able to show anybody, Ronnie or Travis, or anybody what you're doing with the Logix?
No, Ronnie's actually gone and watched some of our videos.
Good.
Travis is very, very hard to get any time to sit down. He's
yeah.
Him and another guy's more or less sharing responsibility for plant manager of Newton Grove.
Yeah.
And they've been doing a lot of layoffs and having a lot of meetings because of financial stuff, you know, because we're just like everybody else, man. This coronavirus is hurting us.
Yeah.
You know, so he stays in meetings about all the time.
Yeah.
All right, let's see. It's fixing to pull up now.
What does Ronnie think about the classes he's watching?
Oh, I'm gonna tell you what, he's impressed with what we're doing with this program right here.
Mm-hmm, yep. Mm-hmm, yep.
All right, so
I figured he would be if he would just look at it.
Sure.
I tell everybody it's really amazing what we're able to do, and the Lord's blessed us big time. You know.
Mm-hmm. Yep.
I went from being upset to feeling a lot better with being able to have Zoom and being able to get the Rockwell software the way it is. Rockwell was double generous to us compared to what another generic company was going to let us do. Some generic software that was going to be kind of mimicking this would have been like 45 days at the most, you know.
Right.
And then Rockwell doubled it, and I thought, man, that is just man, that's a gift from heaven right there, man.
Are you seeing my page?
Oh yeah. Yeah, you're probably going to have to make it small. Once you download, you have to make it smaller. Yeah.
Okay.
Yeah, I would love to get into some of the Siemens stuff and find out about their drivers like you're using now, and then the software, how it looks. It probably would be a good thing for me to if you can do me a favor. This will help me out, and I'm going to ask Mason Cottle to do the same thing, because Mason works in a winery that's got a lot of Siemens PLCs.
Uh-huh.
He works at Duplin Winery.
Right.
The guy that was in our session tonight, and his daddy is I think his daddy's in charge of maintenance there.
Right.
They got him in maintenance now. And if you could do a survey, if you could find out from Billy, get kind of a general idea of what kind of Siemens controllers they are, some specifics on them.
Right.
And is it one software package that y'all use? If it is, what package is it?
They're working in the same building I'm working in.
Uh-huh.
And I should see them tomorrow.
Right. So what I would like to hear would be, I would like to find out what is the most popular type, what kind of controls do y'all have as far as what PLC models do you have?
Yeah, I'll try to find out tomorrow, because actually James Adderman, Billy's like me, he's the maintenance man. James Adderman is the one that's over all of the computer parts of the new machines.
Yeah.
He's the one that done the ordering and stuff, and he'll be in there tomorrow also. So I'll get with James and see what kind of information I can get you.
Right. If you can find out about the PLCs themselves, model numbers, and also what kind of software. Are you using one software package to do all of it?
Right.
And like with our stuff, we got RS Links, and then we got Studio 5000, and find out with them what kind of driver program that they got, like Links, and then their Logix program.
Okay.
And and then I'll find out from Mason what they're doing down there, and it may be the same stuff. And if it is, then it will probably be worth it for me to look into getting some of it and start including it.
All right, you ready?
Yeah. Uh-huh.
So toggle that.
Right. And then once you highlight your start button, you can hit I think Control T,
mm-hmm.
and then Control T again. Right. Yeah, and that's a fast way to do it instead of having to right click both times.
All right.
I think I missed it. Yeah, it was going so fast. Hit your stop button. Yeah, my brain's getting sluggish this time of the night. Yeah. I'm getting ready to eat supper in a minute. I hadn't had supper. I've got some hamburger patties in there and gravy. And I toggle that off. Y'all see it running? I see the second one come on. Yeah. Now, if you could trigger one of your well, you want to toggle that start button off for one thing. Now trigger one of your overloads. That's good. You see how it cut everything off?
Yes, sir.
Isn't that amazing that you can do that sitting right there, man? And you don't even have a physical machine to do it on.
Yeah.
It is. It's a blessing. I thank God for it, man. Really. I would feel bad about the class if we were not on this level right now. I would really feel like it had fallen short, you know. But honestly, you're learning more. You're getting a better grip on the software than you might have on campus, to tell you the truth.
Yeah.
You're getting stronger on software. If we were on campus, a lot of my time will be tied up on checking physical wiring on labs and all, which is good, which needs to be done.
Yeah.
But you wouldn't get as much time. We would not be focused on software as much, you know. So you're getting stronger. You're getting stronger with that for sure. And you know, I'll say this: next year, well, you would not need to take this class again. You just wouldn't, because you know you're in the field enough to where you're not going to need to come back to get this again. You know.
Yeah.
You're just going to need to learn your controllers you got with whatever software you've got, and you won't even, there won't be no turning back for you. You know, you won't have to come back my way.
Yeah, that's a lot of the reason why it's, you know, they're gonna have me out there about 4 to 6 months riding with the, you know, guy that's been out there for 30 years. He's because you're gonna run into some of the old stuff,
right?
Which he knows all of that, but he also is very competent in all the new stuff also.
Yeah, that's good.
I'm gonna be learning a lot.
That's good. And what I would do is keep plenty of room on your phone for doing recordings.
Right.
For you know how to do video recordings on your phone?
I do.
Well, what I would do honestly on anything critical that if he's giving you like a really important session on something that you want to make sure that you don't forget, you know, or that you may forget, then I would record him teaching you that, you know, get the audio and the video there and make videos of him teaching you some things, you know.
Absolutely.
If there's a lot of detail in it, I would be making videos and saving them.
Mm-hmm.
You know.
Yeah, I do. I keep a lot of notes too. Generally when I'm training like that, because I about 3 years ago, Glenn Strickland, he was one of our maintenance men. He retired. They let me kind of shadow him for about a year, you know, when he had stuff to do out there on the floor. And I kept notes of, you know, when he showed me something that I didn't know, I'd make a note of it.
Yeah.
You know, I go back and do it 2 or 3 times, then I got it. So
that's right. Yeah. You'll be a field service rep is what you'll be. You'll be a field service manager after a while.
I hope so.
Yeah. Yep.
Hey, let me ask you a question, Durwood. So I got the EL 117, and this is the 128, correct?
That's right.
So the 113, that's the one for the fall.
Well, that one and 111. If you could get both of them, then you would get your certificate in May.
Right.
And listen, you really ought to ask them if you can do it, because the only difference between the two that you would need to be on campus would be the ELC 111. You need to be on the campus on Tuesday from 12 o'clock noon to 2 o'clock, and that's it.
Right.
2 hours once a week. And then
I can run it by them. I don't think they'll go for it, but I can run it by them. Because, you know, with what I'm doing now, I could probably do it if I was still working with Ronnie. But being on, you know, them guys, man, they're liable to be, you know, their first call of the morning is liable to be in Duplin County.
Yeah.
and we never know where we're going to be. And I don't know when you're going to have the 111 again.
It'll be a year later.
Yeah,
it's once a year, you know.
It'll take me a long time to ever get that one.
Yeah. Mm-hmm. Yep. We may, you know, the next year it will probably flip to nighttime because we flip it each year, you know.
Well, I figure what I would do would be I want to take the class in January.
Yeah, you'll learn a lot with that one.
And I figured I would do that. That way, I'm not getting out of the routine of going.
Yep. Mm-hmm.
And then in the fall, you should offer the 111 at night, and I could take it and complete it. So.
Well, right, exactly. Yeah, it should be at night because we flip it each year. If it's up to me, it gets flipped. You know.
Right.
Yeah. Yeah.
But okay. I'll ask them about being able to take the class.
Yeah, just tell them basically all it is this. You're backing up to the very first electrical class that you really need to get some basic to understand the electricity itself.
Right.
It'll help you as a troubleshooter to understand electricity better. And it covers Ohm's law, doing calculations on voltage, current, resistance, wattage, doing series parallel combination circuits with light bulbs and doing you're doing calculations in that class you hadn't done in any other class.
Oh yeah.
Electrical calculations and understanding better the relationship between voltage and amps and current and wattage, and it just gets in depth on electrical theory. And you would only need to be on campus on Tuesday from 12 to 2. On Thursday, it would be a live Zoom class like I'm doing now. It would be a live Zoom class from 12 to 2. But it would also be recorded that you could see it later.
Okay.
So
if they did let me do it, the Thursday live Zoom class, I could go on Moodle and watch the class, and y'all would give me credit for taking the class.
That's right. That's what I'm doing now, because if I see somebody click the link to see it, I'm counting them as being here.
Yeah, the 2 nights that I wasn't able to come, you can see I clicked on Moodle and watched them.
Yeah, I'm keeping records of all that. I'm going back on the weekend and looking at the logs, and it keeps a log of who clicks them,
right?
Who watches, and then I'm recording that as being here. You know,
right.
So that's another thing that's amazing to me, that them logs are being kept that way. You know,
right.
I set up a configuration when I configured the recording.
Mm-hmm.
Like tonight, when we get done, when I upload this video to YouTube, and then I put the link in Moodle, I'll configure that link so that it keeps a record of who watches it.
Right.
And then I go back and see the logs later, you know. So
okay.
So it works out good. Okay. Well, you have a blessed evening, man. And
all right, Mr. Durwood, thank you for your time.
You're welcome. And we'll see you Thursday, Lord willing. So you know.
All right.
All right. Tell Ronnie I said hey, and tell him I have not forgotten that fish. Tell him we're really looking forward to that fish plate.
I will. I'll tell him. All right, Durwood. Good night.
Have a good one. Good night. Mm-hmm.